and refill my coffee, and then we're going to go from there. There we go. So the train is an M1. Yes. That's correct. Not really news, but you might find this a good read. Okay. Bandit, what was that big space news that you were talking about? I don't think I ever opened it. Huh. Alright, well. You need a 64-ounce mug. Yeah, something like that. Alright. Astra to launch from Slick 46. Cool. Cool. Need a slug to attach the locomotive for the hump yard. Yeah, man. See, we could do that. It'd be cool. Alright. So. EJ's Space and Rocket review. What do we want to watch for the break video? It was just this. New Clips contract for Intuitive Machines. That's why they released that stuff about the Nova Sealander yesterday, Thomas. It makes a lot more sense now. Cool. We deliver? Okay. We deliver it is. You want to watch the re-entry thing with Mr. Parameter? Oh, drummer, that's something, man. You want to watch this. Yeah. Is that Elon with a Wario outfit? Yes. Yes, it is. Okay. Ooh, audio's really low.
Okay, and the port restraint is out. Here comes the spin.
Yeah, we see it down
Now
here, Bill. It's beautiful.
I'll be back in a second, guys.
Okay, Mike, we're at 52, coming back down to 51 RPM.
Roger, we copy. You guys look good. And Columbia, Houston, everyone down here is go for deploy with 2 minutes left over Hawaii.
And so is everyone up here.
Roger, we copy.
Mike, we hope the TV comes out. It doesn't play back very well on a monitor, but we're relatively sure we got it. And we, by the way, still have that beautiful satellite inside. It's traveling just below it.
Roger, we copy, Bill and Joe, and got a lot of happy people down here. You guys did good work.
Okay, Mike, we delivered. We got SBS off on time. And if you're interested, I'll read you the pad.
Roger, go ahead.
Deliver the crew of Shuttle Mission 5 did. Only 8 hours into the first operational flight of the Space Shuttle program. 5th flight of the orbiter Columbia. The first 4 missions were test flights to prove the space transportation system could provide access to low Earth orbit on a routine basis. Those missions laid the groundwork for the operational era. Shuttle Flight 5 was the beginning of that era. The primary purpose of the mission, to carry 2 communication satellites into orbit, deploy them from the payload bay, then return to Earth.
Columbia, Houston, 30 seconds till LOS, and everything is still go down here for deploy.
Roger, Brian, we copy that. Thank you very much. We're looking forward to having a good one.
Roger, and good luck.
Okay, Houston, this is Columbia. We are 2 for 2. We deliver. Hey, Roy, are we down now? That was, are we on the ground?
Absolutely.
A flawless landing. Only minutes after sunrise at Edwards Air Force Base, California, ended Columbia's 5th mission. Looking slightly weathered, the orbiter had traveled over 10.5 million miles in 5 flights, spent 24 days on orbit, and circled the Earth almost 400 times. It would now return to Kennedy Space Center, Florida, for refurbishment, to be launched again on Shuttle Flight 9. The newest orbiter in NASA's fleet, Challenger, would fly on Shuttle Flight 6. Many weight-saving improvements had been made. The orbiter itself was almost 2,500 pounds lighter because of structural changes. The external tank weighed 10,000 pounds less than the one used on Shuttle Flight 1. The solid rocket boosters were almost 4,000 pounds lighter. The 3 main engines were upgraded to 104% of rated thrust. A blanket-like thermal material replaced 600 thermal tiles in non-critical areas. And all 30,000 tiles were densified to improve their durability. This stack could carry over 17,000 pounds more into orbit than Columbia.
Minus 15, 14, 13, 12, 11, 10. We'll go for main engine ignition. 7, 6. We have main engine ignition. And liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a roll program.
Houston copies, Challenger. And some late news for you, Story. We got a go for deploy. We have a go for deploy.
On Shuttle Flight 6, Challenger's cargo, the Tracking and Data Relay Satellite, TDRS, and its solid propellant inertial upper stage rocket, the IUS, weighed almost 19 tons. TDRS was the largest, most advanced communication satellite launched to date,
That is correct.
a major accomplishment in space communications. TDRS is launched from the payload bay by ejection springs, released when explosive bolts are fired. After shuttle moves a safe distance away, the first stage of the IUS rocket fires to boost the satellite from 150 miles to 22,300 miles in altitude. Then the first stage separates. Shortly thereafter, the second stage of the IUS rocket fires to circularize the satellite's orbit. Solar panels and antennas are deployed to provide power and tracking and data relay capability. Having attained a circularized altitude of 22,300 miles and traveling at the same speed as the Earth's rotation, the satellite will remain fixed in orbit over the same location continuously. Later, the first TDRS will be joined by 2 more identical satellites. The 3 will form a space communications network, providing almost continuous coverage to Earth-orbiting spacecraft, not the 15% ground stations provide. The network will be able to track 26 Earth-orbiting spacecraft simultaneously. And because TDRS satellites only relay data, they do not process it, 20 times more information will be handled by this network than could be by ground stations. All data will be relayed directly to the primary NASA ground terminal, White Sands, New Mexico, and from there via domestic satellite to other NASA centers.
Got a good picture here. Good picture. Hello there, we're with you over...
Launch of TDRS was on time and nominal. First stage firing of the inertial upper stage also went well.
And Sunnyvale and White Sands send you a special attaboy.
However, halfway through the second stage firing, ground controllers lost communication with the satellite. It was an hour before even intermittent signals were picked up. They indicated TDRS had not yet separated from the IUS, and that both were tumbling at a very high rate of speed. Receiving only intermittent signals from TDRS, using short-life batteries which would soon be depleted, and getting no response to signals sent from the ground, made the outlook for TDRS bleak. Several more hours passed, and then something remarkable happened. Experts still aren't sure why, but either an automatic timing mechanism was engaged, or onboard systems finally acknowledged repeated commands from the ground, separating TDRS from the IUS.
Well, I do have some words.
Now on its own, the satellite stopped tumbling. Ground controllers commanded deployment of the solar array and antennas. However, they quickly learned TDRS was way off course and drifting farther every day. Their only hope of getting it back on course was to use the tiny hydrazine thrusters originally designed for minor attitude and velocity adjustments, not for boosting the 2.5-ton TDRS over 8,500 miles farther into space. But at least the satellite was not lost. NASA officials immediately put their plan into effect. Meanwhile, Shuttle Flight 6 continued as planned.
Okay, we're back with you, Mila, for about 12 more minutes. Got a good TV picture again.
Roger, Houston. Got the hatch closed, and we're waiting for a go for deep rest on time.
That sounds great, Bo.
Copy, we have a go for deep rest on time.
That's affirmative. You have a go. And Challenger, Houston's with you over Guam for about 7.5 minutes.
Roger, hatch is open. EV1 is halfway out. They're configuring the airlock. Get ready for Dawn to come out.
Okay, we're watching.
Houston, do you have a suggested setting for the DAC camera now in the sunlight? Okay, Dawn.
This was America's first spacewalk in 9 years. The astronauts were attached by safety tethers to slide wires running just inside the payload bay. They wore a new design in spacesuits, also called extravehicular mobility units. A portable life support system was worn on the back, eliminating the need for a lifeline connected to the orbiter. These suits are not custom built for each astronaut. Tops and bottoms of different sizes can be mixed. They are also more flexible than previous spacesuits. The crew removed tools from a storage locker in the front part of the payload bay. Then moved aft again. Using a cable run through a winch mounted on the bulkhead, then tied to the cradle that had held the IUS, the astronauts demonstrated they could have lowered the cradle manually had commands from on board failed.
There is Velcro here over the outer edge. That's what I'm going to do, sorry. Velcro in the inner edge over there. The Velcro, I'm afraid I'll kick it loose.
Winch operations were tested on the front bulkhead using an exergenie as a load to see how many pounds the winch and line could handle.
The back pocket. Okay, I'll try that.
Lastly, the tools were re-stowed, and the astronauts re-entered the spacecraft.
Indian Ocean for 2.5.
Perhaps the most visually spectacular mission since America's first landing on the moon, Shuttle Flight 7 gave us our first glimpse of the orbiter from a distance.
Another space first.
John, we have had one more of those intermittent dropouts, but the spas came right back up and no other problems.
Thank you.
All right, I'm back. You guys see this picture?
The magnificent views were provided by a European payload called SPAS.
You see that?
We switched over to view looking at spas.
Like,
Copy.
Roger that.
SPAS is an acronym for Shuttle Pallet Satellite, a unique, reusable space platform built by the West German aerospace company Messerschmitt Balkov Blanc.
it's a drone shot of the
Generous
shuttle.
financial assistance from the West German Federal Ministry of Research and Technology.
Best wishes to those folks from MBB who built this spacecraft. It's a real
In addition to having American television and film cameras mounted on SPAS, 10 experiments belonging to the West German government, the European Space Agency, and NASA were on the platform. MBB wanted to validate the satellite's design and prove experiments could be operated while SPAS was free flying. NASA wanted to show the remote manipulator system could handle the 2.5-ton payload.
adequate reading. And TJ, we just turned on the
That's
mass tech to warm it up. I assume that you wanted us to do that.
Affirmative, Sally. Thank you.
Okay, TJ, we're with you, and John performed a beautiful release.
Wonderful, wonderful.
The orbiter's ability to station keep with SPAS was also demonstrated. At this point, they are 1,000 feet apart.
330 meters.
Here, SPAS and Challenger are 200 feet apart. Thrusters on board the orbiter were fired to record the effect on SPAS.
I could not get the spas right now.
About 60
SPAS was
meters.
rebirthed for return to Earth.
They sure are nice.
That's so cool.
Told that some crews in the past have announced that we deliver. Well, from Flight 7, we pick up and deliver.
Oh, man. Yeah, right, Solar Lander? She's pretty cool. All right, that's from We Deliver. That's a NASA documentary from 1983. Pretty awesome footage on that one. I show that one a lot from time to time, but, yeah. Pretty freaking cool. Anyway. Yeah, Thomas, soon, right? Yeah, freaking this picture. So, welcome to Space News. We got a Starship presentation that should be happening soon. Oh. You can't tempt me with a good time, man. Shoot. But, let's try to get through everything else here. Oh, I freaking wish, man. I freaking wish. That, dude, that looks aesthetic as frick, man. So, Nomex on the backside of the stainless steel when? When are we going to do that? Put Nomex on the back. For old time's sake, right? 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 Like, what's wrong with that? That's fine. It's pretty awesome, man. I mean, soon we're going to see something like that. Lunar Starship is going to look like that, minus the tiles. All right. Anyway, let's get the rest of the news here loaded up. So, a little bit of news with Intuitive Machines. We got some news from Astra here. We got an Electron launch that's happening after the Starship presentation. We got a thread from Rocket Lab regarding that mission. And we got a new video from Blue Origin. So we should have and obviously the Starship updates. So video from the 1980s looks so bad to video in 1080p or 4K. I mean, I guess, bro. All right. So here, let's check out this video from Blue Origin. It's not very long, but here, let's jump in. So one Starship and Shuttle paint scheme. I don't know, but it'd be cool. This one-to-one Pathfinder will be utilized for several mission operation tests, including route verifications, recovery and refurbishment simulations, stage mate simulations, and vehicle rollout at pad. All these operations are testing moving New Glenn closer to the first flight. All right, what do we got? Oh, this is footage from when they moved the Pathfinder out the other day. Yep. Holy crap, man. Look at that thing. Nice. Very nice. Look, I mean, look, Blue Origin built another factory down there. There's another one. Another one. Yep. Soon. Soon, man. Wasn't it cool? That's probably the one good thing we got out of that press conference about the Artemis program. They talked very briefly about New Glenn, and New Glenn is SLS derived. Yeah. The tooling that they use to make New Glenn is the same as SLS. It's the same SLS tooling. It's just for a 7-meter diameter instead of an 8.4-meter diameter, which is that's pretty cool. I think that's really neat. How long have they been working on New Glenn? It's been off and on. It's been off and on. See, guys, that's the thing about rockets, dudes. You still haven't put new Jeb on Kerbal X. Oh, yeah. The thing, like, progress should start happening very rapidly because the hardest part of getting this right, okay, so, like, it's like when we make the SSTO in Kerbal. That, like, mission mode is supposed to represent that. Look at, has it been flying a lot? No. Will it fly a lot? Oh, yeah. But look at how much I spent on the ground getting everything figured out. All these little things figured out. All the tooling that you need to make. All the jigs that you need to make. The welding processes. How are you going to do the welding? How are you going to test it? And that's for, like, every single component. You know, let alone the rocket body. You have to do that with everything. And then hopefully it comes all together, and if you did your homework right when you go to launch it, it works, right? Long story short, that takes a lot of build-up and then a lot of action all at once. So Pathfinder, when you see a company roll out with a Pathfinder, that means they're pretty dang confident in all the equipment that they make to be able to, A, with the Pathfinder, move the booster around, and B, integrate the damn thing. So New Glenn they've been working on New Glenn for some time. But you're at the point, just like with SLS. They worked on SLS for a long time, and then all of a sudden we just started getting flight hardware out of nowhere, right? There was just flight hardware here, and here. It was everywhere, right? New Glenn will be the same way. Everything just kind of comes together all at once. That's just what happens because when you're using waterfall testing. New Glenn you won't see a lot of it until like right around now, and then it's just going to come at you real rapidly, and you're not going to remember what it was like not having it. You know, that's what happened with the SLS core. You know, everyone's like, oh, SLS is a paper rocket, it doesn't exist, and then all of a sudden Artemis 1 was stacked in the VAB, and everyone's like, huh? Not always, Phonesister. It's always application based. Did you ever see this photo? No, Tomas, I have that opened up. Basically, New Glenn has rounded second and is sliding into third right around now. Okay, all right. Plus points for the baseball reference, Tessa. Yeah, pretty much. Speaking of Blue Origin, how long did they stop progress for NASA and SpaceX with their lawsuit? Was it over a month? 7 months? All right, Tomas, what do you want me to see? What do we got? So this is coming from Thomas Berghardt. Thomas Berghardt is the director of news for NASA spaceflight. Let's see what Thomas is up to. Today's NASA OIG report. NASA OIG is the Office of Investigator General. It's like internal affairs, but for NASA. But it's not like corruption or anything. Well, it kind of is. It's basically the checks and balances for NASA. Let's see what their OIG report is. This is from November 15th. So, guys, it's okay. This was not from this November 15th today. Okay. All right, is this the one that... Oh, okay. Maybe I'm trying to avoid this. Today's OIG report, which projects that Artemis 1 will not launch before the summer of 2022, unsurprisingly, includes some insight into SpaceX's Starship human landing system program. Note that the schedule was before the delays from the Blue Origin protest. Wait, it says, note that the schedule was from before. Okay. Okay, refuel the starships. Refuel lunar starship. Send lunar starship out to the moon. Then send SLS with Orion. It rendezvous in rectilinear halo orbit with lunar starship. Read that. It's not good news. Yeah, well, what the OIG reports, guys, is they're cynics, but they're cynics by design. OIG basically gives you worst case scenario. That's what they're there for. They're to give you that's the worst case scenario. That's what they do. It's not exactly that, but it's important to understand it that way. This doesn't necessarily mean that this is what's going to happen. OIG also thinks Vulcan won't fly on time, and Tori Bruno said, "Yeah, that's not true." So take it with a grain of salt. It's stacked for the first test, but it's going to take 2+ years for the crew launch, and I love SLS, but it's becoming a joke for us that want to see it succeed. TJ, that's why I didn't like what they said in the Artemis presser the other day, man. But you know what? Look, even though I think what NASA's doing with SLS is kind of a bonehead move, I'm still going to cheer on SLS. I'm still going to. I'm not losing faith that easily, even though I'm annoyed, but it is what it is. Let's keep going. I mean, just because they chose a bonehead rebaseline of SLS when it was like 90% of the way through development. That's basically what happened here, guys. SLS is basically like 90% good to go. There's a couple of things here and there that you got to figure out, like Eclipse on Orion. They don't have the life support systems figured out for Orion yet. Well, it's not that they're not figured out yet, but you get the idea. There's a couple of things to button up here, and then it has the flexibility for a better upper stage, etc., and better boosters down the road, which is what it was engineered to have basically in the beginning. The SLS core stage is designed for the EUS. It's not really designed for the ICPS from the baseline configuration. What they chose to do here is basically redesign it for better flexibility down the road and more longevity, whatever the heck that means. I mean, I don't know how you can figure out that it's not going to be good. It's not going to be a long-term solution if you don't fly the thing and get some flight data at some point. That's where it doesn't really make sense. But I mean, TJ, I've always said that SLS needs to fly more. Like, I don't see everybody touts that, jobs program this and, stagnation that. That's not what's going on here, guys. Because if NASA was a jobs program, wouldn't you want to put these people wouldn't you want them to do more work? Wouldn't you want them to make more rockets? Like, we understand that, if you really want a jobs program, you'd want to do something like Apollo that puts people to work for a very long period of time. Right? Like, hello? Hello? How did ICPS even come to existence instead of straight up going for the EUS? Cost. Jazos. Yeah, they rebaselined Ares 5. Yeah. See why I sounded the alarm bells the other day, man? When you hear rebaselining, usually nothing good comes of it. Every time we've done that in NASA's past history, it hasn't ended good. It's true. They decided to rebaseline Ares 5, and they decided, it would be more cost effective if we started with an interim stage, and then down the road, develop the stage that really should have been designed with the rocket from the beginning. It'd be better to do that. And it would also be better to use shuttle engines because, you know, it'd be better to put people on top of SLS instead because that gives us a better pathway to the moon. Or I don't know. Yeah. Long story short, rebaselining is usually bad news. And time. The ICPS was supposed to make SLS fly around 2017. Yeah, basically they looked at the Constellation program. They looked at all the stuff that they didn't like because they got sticker shock from it. Turns out going to the moon is expensive. I know. Funny story. Expensive. And then they just kind of picked and choose the stuff that they liked, and they picked and choose parts that they wanted to keep going from the shuttle program, and then they picked and choose parts that they wanted to keep from Ares 1, Orion, and parts that they wanted to keep from Ares 5, you know, heavy lift capability, and then kind of cobbled it together and made SLS. All in the name of cost rebaselining. See, you see why? I heard that buzzword and went, no, 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 you know? So, yeah, caveman, it's stupid, yeah. Anyway, hey, Emma, when's SPAC? Well, SPAC is right now. So would you say that SLS is in the position of the wide receiver waiting for the quarterback to make the throw? What is it with you and American sports references? Stop doing that. Nah, Tessa. They're hating. SLS isn't even playing the game yet. SLS has been practicing for the past 10 years in hopes of doing really, really well on the first time they play a football game, right? Like, but hey, anyway, like even though I have all these criticisms, guys, I'm still not going to talk bad about SLS. It's better than nothing. Would you rather have nothing? And I know people say like, "Oh, EJ, isn't that a little bit of hyperbole?" Well, they started rebaselining Ares 5, and then we had nothing for 10 years. So no, that's not hyperbole. No, absolutely not. I'll take it. I'll take SLS is fine. At least it has an architecture. It has flexible pathways through an architecture that could be useful down the road. Like getting the right upper stage for it and getting the right lander for it, etc., etc. Or not the right lander, that's not the right way to say it. Getting basically a viable pathway to rectilinear halo orbit so SpaceX can do the rest, right? It's not a bad piece of equipment. I'll take it. I'll honestly take it. That's fine. I mean, would I prefer a Saturn V? Sure, absolutely. Duh. You wouldn't? Well, I would have used a skilled American motorsport, but you don't have one. Oh! You guys smell that? You guys smell that? It's the sound of Tessa being wrong. Ugh. Stinky. Saturn V is better than SLS? Yeah, Smib, of course. At least when in the Block 1 variant of SLS. Yeah, absolutely. But Saturn V is better than SLS in the same way that a 1967 Mustang is better than a 2015 Mustang. Right? 67 Mustang is fast and good for the time. It'll get wrecked by a 2015 Mustang, right? But, see, then again, the Saturn V was built with a pathway to the surface of the moon from the start. SLS wasn't. That's kind of the thing, you know? And that's where it's like the 67 Mustang in that regard, because it's a 67 Mustang. You know, it's a 67 Mustang. Dude, honestly, if I had the choice between a brand new Mustang and a 67 in mint condition, a brand new 67 Mustang, I'd take the 67. even if you decided you didn't like the 67, you could sell it and buy 30 2015 Mustangs, right? Like, I'm going to spend a little time and come up with a cricket analogy for the SLS program status. Do it. Do it. Out of all past OIG reports regarding this report, I honestly can't find any faults with their assessment, assuming NASA is operating as they say they are, which I have no reason to doubt. These pains that we are experiencing with this rebaselining actually does extend from Jim's administration, not not as a knock to Jim. Jim was on the right track, but the change with NASA program management necessary to hit the schedule is, of course, causing pain points doing a new process for the first time. Yeah. Nice, Soapbox. Hell yeah. It's a nice car. Well, the Mach-E is a shoe username. The 2021 Mustang is pretty cool. Yeah, Rocket Guy, do you think it would be prudent to say that Jim got handed a bunch of lemons with NASA and he made lemonade with it? Do you think that would be prudent to say? NASA administrator is an executive branch cabinet position. Well, it's not a cabinet position, but it kind of is, but it kind of isn't. Like, and you get appointed by the vice president or the president. And Bill got lemonade and made piss out of it. Rocky, I think. See, what I like with Jim is because Jim inherited a crapshoot of a human spaceflight program, like. No low Earth orbit activity, but it was coming, and a rocket that has no mission. So he tried to make lemonade with the lemons that he was handed. He tried to fix things. He's trying to get going again. I think he was handed a lofty goal, and he saw that agile compartmentalization was required to hit that with too short a time to think these things through. Yeah. Yeah, literally making lemonade. Yeah, right. Yeah, Tessa, pretty much. 5 minutes until the Elon presentation. Okay, well, we can go over the rocket. I'll jump through the rest of the rocket news real quick, dudes. Yeah, I'm gonna have to do more reading about this rocket guy because I'm not. Now I'm like, but I think my point still stands. That, throwing Jim under the bus like that, like what they did in the press interview, is totally uncalled for. But, hey, it is what it is. Came here, what's that from Nick? Let's see. A Raptor feed for the upcoming booster. Crazy. Alright, let's see. NASA awards Intuitive Machines a $77.5 million contract under the Commercial Lunar Payload Services Program to deliver 203 kilograms of payloads to the moon's surface in 2024. Yeah, God, I really didn't like that. And it's not so much, I don't like it when people that run organizations like, you can't blame anybody else. You're the one that's running NASA right now. Like, it's... Like, playing the blame game is something that toddlers do. It's very gross. I don't like it. It's not a good look for NASA. 203 kilogram payload is wrong. It's 203 pounds. Okay. So 50 kilograms. Interesting, Kamer. Sometimes you have to throw someone to the lions to appease the unwanted masses. And who in spaceflight liked that press conference? It's not about the masses, Tessa. Let's just play it. So, let's play devil's advocate here for a second. Why would Bill do that? Jim appointed him to the National Space Council. He helped come up with the Artemis program. He helped come up with it. Why would he do that? Well, we know Bill is very good at playing Rule 8 games, right? He's very good at it. He's been doing it for a long time. Why would you throw Jim under the bus? To get people in high places that didn't like the past president and his administration to fund NASA. That's why I would do that, right? Think about it. Once again, we're just playing devil's advocate here. Like I played devil's advocate with Jim trying to get... I think that him choosing SpaceX and only SpaceX for HLS was not an accident. They did that on purpose as a way to try and get NASA more funding. Why would Bill do that? Why would he do it? Why would he throw Jim under the bus like that? To get more funding. Now that I'm thinking about it, he did talk about funding right after that. I mean, neither would IS Master. That was a stupid thing to do. It's not a good look for NASA. The biggest blunder I see is that Artemis is separated into 3 separate programs run by different boards and offices. All these boards do is share information at annual sync reviews. Do you see a problem with 2 major deeply coupled programs that significantly rely on one another with only annual reviews? This rebaseline implements a set of boards to manage these programs together more closely. Why was this not done sooner? Like, I'm actually pissed about this. Yeah, Rocket Guy, that should have been done from the start. And that goes back to Constellation, when they merged exploration ground systems, exploration development systems, and the HEOMD all into one thing. They consolidated everything down and compartmentalized everything. Well, yeah. I mean, that goes back to canceling Constellation, dude. Yeah, it just proves that SLS was a crapshoot from the beginning. The people that came up with that, the people that decided to get rid of Constellation, and the people that came up with SLS as a response, yeah, not good. Dude, Rock Guy, you know good and well. There's a very good reason why I always beat that $30 billion drum. I don't think people realize how big of a mistake that was. That was really not a good idea. So he's playing a political game to get money. He is a politician, Tiggs. So is Jim, to be fair. Yeah, that sounds right. And we know Bill's smart enough to do something like that. I know he's smart enough to do something like that because in his Senate testimony, he kept saying, you want to get NASA more funding? Infrastructure bill is the way to do it. You want NASA you want to get more jobs for your congressional district? Fund NASA's infrastructure needs. He kept doing he plays that game, dude. It's like playing a poker game. And once again, I'm not a poli-sci person, so I don't freaking know. I completed the mission you gave me. Here are some pictures. Did you build that moon rocket? Oh, very nice. Very nice. Very nice. I agree, Hellfish. I think that's why Jim hasn't spoken out about what Bill did. He knows the drill. Yeah, probably. So compartmentalizing is good, but how do you not have a single source of truth manager that oversees both of them? This process is not new. Scrum of Scrums and SAFE and other large-scale program management frameworks for software have known of these issues. Yeah, once again, canceling Constellation was dumb. That was the stupidest thing you could have done. Like, stupid. And that was done because we were in the middle of a recession and the new guy didn't want to be, I don't want any more of the same. So they tried to shake up the status quo, and I guess the kind of like half benefit of that is, they champion the commercial orbital transport services, which, once again, credit where credit is due. Good call. Very good call. But the other thing to understand is that the commercial orbital transport services program was not the way it was explained is that you canceled Constellation and then you moved to a commercial model. The reality of that situation is that the commercial model was already there and they just picked and chose pieces of the Constellation program that they liked. And then said, look at what we came up with. But then again, championing it is not the same as creating it or, even carrying the torch, Elon is talking. Elon is going live. Oh my gosh, we gotta stop everything and hold the press. Here we go.
And I'll mute me.
Oh, hey, little guy.
Great. Thanks for having me. I think there may be an introductory video potentially that we can play. Okay. See, I don't know if it does have sound, but maybe you'll.
Oh, this is kind of cringe.
Andrea, can you check the sound?
Cool.
It is cool.
Rocket, but
That a boy, X.
rocket on a big car.
Wait, did the kid just say car or cool? He said car. Hell yeah. Hell yeah. Hell yeah. I like this. I like that kid.
Let me try that again. I was muted.
Okay.
I'm
The
just
sound
gonna.
isn't essential.
I'm just gonna spare you guys that. Yep.
Hi. Hi. Hi.
I love this.
big, 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 big,
The subtitles.
buttercup.
Yes. The subtitles, they're trying to subtitle little X there. That's cool. This is the best, man.
B.
Oh, that's gnarly. That's the down. Oh, that's so cool, man. We watched this footage yesterday. Dude, so gnarly. X? Smib? Is this kid's name? I'm kind of like, should I get the Starbase video up and sync the sound? Oh, little guy. Oh no! Now I feel bad. He's still saying, where am I going? Aw.
Great. So that was just an introductory video regarding the Starship program. That was all real, no CGI there. So what we're aiming to develop with Starship is a generalized means of transporting large amounts of mass or people, but just in general large amounts of mass anywhere in the solar system. The idea behind behind this is to have the first fully and rapidly reusable rocket, which is that's really the holy grail of rocketry. If you can have a fully and rapidly reusable rocket, orbital rocket, then the cost of transport of a ton to orbit drops by about 2 orders of magnitude, maybe better. So, just as it would for really any mode of transport, if you say had aircraft or cars that were not reusable, you would see very little use of aircraft and cars because you'd have to buy a new aircraft every time you went somewhere. And if you traveled somewhere in a car that was single use, you'd have to obviously tow a small car behind you just for the return journey. So I think this is quite profound. If we are successful, and at least from a design standpoint, it appears to be, all of the calculations close for having a fully reusable 100-ton to low Earth orbit capability. The vehicle is very big, so one of the things that helps with reusability is scale, because, for example, the electronics that control the brain of the vehicle, if you will, does not actually get any heavier if it is a big vehicle or a small vehicle. So things like avionics and control, inertial measurement, sensors and whatnot become round down to basically almost no percentage of the mass for a big vehicle. Whereas for a small vehicle, obviously that would be much more of an issue. So scale certainly helps. And then we're using the most advanced engine cycle, which from a physics standpoint is the best. You can extract the most amount of momentum for a given amount of fuel or propellant, which is a full flow gas staged combustion engine. That's the Raptor engine. There are currently 29 of those on the base of the booster. We'll be expanding that to 33. At 33 engines and with the Raptor 2, we'll be doing about 7,700 metric ton force of thrust on liftoff. So it's about 2.2, 2.3 times the thrust of a Saturn V. So it's really a very big vehicle. It's the biggest rocket ever.
That's awesome.
Ever designed. and we're close to our initial launch, our initial orbital launch. We've done several suborbital flights and have been able to land the vehicle successfully. The first orbital flight we're hoping to do in January. So we've completed the first orbital booster and first orbital ship, and we'll be complete with the launch pad and launch tower later this month, and then we'll do a bunch of tests in December and hopefully launch in January. There's a lot of risk associated with this first launch, so I would not say that it is likely to be successful, but I think we'll make a lot of progress. And then we've also built a factory for making a lot of these vehicles. So this is not a case of just one or two. We're aiming to make a great many. Ultimately, I think in order for life to become multiplanetary, we'll need maybe 1,000 ships or something like that. But the overarching goal of SpaceX has been to advance space technology such that humanity can become a multi-planet species and ultimately a spacefaring civilization, and to make true the things that we read about in science fiction and have them not always be fiction. I think this is actually quite important. Well, long term, it's essential for preserving the light of consciousness. Eventually, something will happen to Earth, hopefully not soon, but either natural or man-made, that would cause the end of civilization. So the probable lifespan of civilization is much greater if we're a multi-planet species, and ultimately even go beyond our solar system. But the first step is being multi-planet, Mars being the only realistic option for that. So I think from a standpoint of, like I said, from a standpoint of preserving the light of consciousness, and which I think we should regard as fragile, I think it's extremely important that we try to become a multi-planet species as quickly as possible. Obviously, along the way, we will learn a great deal about the nature of the universe. And it will be possible to have many more space-based experiments if you have a very large vehicle capable of transporting things to orbit or the moon or anywhere at 100 times less than it currently costs. So it offers sort of profound possibilities, and I think this, there's a fundamental juncture in the history of really any civilization on a single planet, which is, do you get to the second planet or do you not? And I propose we do. And I think we should do it as soon as possible. The window of this opportunity is opened now for the first time in the 4.5 billion year history of Earth. It may be open for a long time, or it may be open for a short time, and I think we should, be hasty so that just in case it's only open for a short time. So like I said, I think this is very important for the long-term preservation of the light of consciousness. And of course, we'll naturally, we'll learn a lot of science and develop a lot of technology along the way. So that's what Starship's all about. We have an interesting project that we're working with Seoul Perlmutter at Berkeley on, which is to have a really big telescope. This is taking a ground-based lens that was intended for a ground-based telescope and creating a space-based telescope with it. So that could be, I think, pretty interesting, and we'd love to do other things as well. So, and I think people may know that NASA has selected Starship for the transport of astronauts to the lunar surface. So we look forward to doing that for NASA. And And then I think, it really could be, it has the ability, because of the mass transport capabilities of transporting enough mass and people to the moon to actually have a permanently occupied, I think, base on the moon. Much as we have like a permanently occupied base at Antarctica, we could have a sort of a moon research station, which I think would be amazing. So, yeah, I think, anyway, this is a very profound vehicle, and nothing really like it is being developed, and I don't think anything quite like it has been even proposed. But it has the potential to affect human destiny in a very profound way. So I'm happy to answer any questions. I'm not sure quite what you'd like to know, so maybe real-time questions are the best way to address what people may be thinking.
Terrific. Thank you so much. Elon, from our board members, please raise your hands for questions. And our first question will come from Louis DeMauro.
I think you may be on mute.
Yep, still muted. There you go.
It's just saying thank you for that. It's a rather big vision. I wonder, in order to achieve this goal that you painted, what type of international collaboration do you see to get this done? And, what are the possibilities of actually pulling that off?
Well, we're not assuming any international collaboration. We're building this thing right now, and we're really building it from internal funds. NASA is providing some support because they intend to use Starship for transporting astronauts to the surface of the moon. But this has really been an internally funded effort. Probably, I don't know, at least 90% internally funded thus far, and we expect to reach orbit. Probably, I don't know if we'll get there on the first attempt, but I'm confident we'll get there next year, and we intend to have a high flight rate next year. So it's difficult for us to actually have international involvement because of ITAR. So I'm not sure, and I don't really see anyone outside the US who is building some part of what we need. So yeah, we're just doing it.
That's great. Wonderful answer. Next question will come from Adam Burrows.
A fascinating vision. I don't know where to begin, but I will ask just a technical question. It was surprising to many that I believe you chose stainless steel for the vehicle. I could be wrong, but what were the technical and engineering reasons for that? And don't stint on the details.
Sure. That's I think a very interesting question, because to a lot of people intuitively they would think of steel as being heavy, and rockets need to be light. So well, that seems a pretty odd choice, picking a heavy sounding thing for rockets, especially orbital rockets that need to be very light. I mean, the nature of Earth's gravity being quite strong and a dense atmosphere means that you really have to have an incredibly good propellant mass percentage, and you have to have very efficient engines to get anything to orbit at all. So then why steel? So we started off with an advanced composite. So intuitively, if you ask people who understand materials, they will say we want to make something incredibly light. They'll say probably you would want to use state-of-the-art carbon fiber composite. That's usually what they'll say, and that's what we started out with, which was really a very advanced carbon fiber, and actually it was only made in very small quantities. It cost $130 per kilogram, so it was very expensive material, and there are some challenges if you want to make the primary structure out of carbon fiber, which is that you've got to contain cryogenic fluid, and you need gas in sort of what's called ullage gas, pressurization gas, to pressurize the propellants in the main tanks and feed the engine turbopumps with a given inlet pressure. So if you have a carbon fiber tank, because it tends to be porous and also potentially flammable when subject to warm gaseous pure oxygen, because our vehicle is autogenously pressurized. So the oxygen tank is pressurized with gaseous oxygen, and the fuel tank is pressurized with gaseous methane. The resin and the carbon in the carbon fiber is potentially flammable with hot, pure oxygen gas. So you'd have to have some kind of liner. So when you look at the full mass and complexity of a carbon fiber system, you start having things that reduce the mass efficiency of carbon fiber, such as having an inert liner and being worried about gas permeating through the carbon fiber and that kind of thing. So but it still would be it's still an okay choice. However, we were having a lot of trouble making progress with the carbon fiber because this is a 9-meter diameter rocket. And so you're wrapping carbon fiber with typically, in this case, 60 to 120 plies, depending upon where you are in the tank. And you have to get all of those wrappings accurate and not leave bubbles or separator sheets or all the things that typically happen, or you've got to scrap the whole thing. And then you've got to get good mass properties, put it in an autoclave and put it under a lot of pressure. Like a ferry. And then you need a gigantic autoclave because it's a 9-meter diameter with a 70-meter long boost stage. So this is autoclave from hell. And we just weren't making rapid progress with this material. So then the next thing, the other two materials worth considering are a high strength form of aluminum or aluminium, or potentially steel. So for Falcon 9, we use aluminum lithium, which is the highest strength to weight aluminum alloy that you could use. Very difficult to weld, but that's what we use for the primary structure of Falcon 9. Then, but the problem is it's very difficult to weld. You need to do friction stir welding, and also the material cost is quite high. So, that's sort of material cost, arguably on the sort of $40 a kilogram level, and like very difficult to weld. But then there's steel. Now, the interesting thing about 300 series stainless steel is that its properties at cryogenic temperatures, its strength properties increase dramatically. So if you were to look at the material properties at room temperature, you'd be like, oh, it's not that great. But now go look at the temperature properties at liquid oxygen temperature. Oh, actually much stronger. Also no meaningful increase in brittleness. So it still has high toughness at cryogenic temperatures. It is much stronger, depending on how cold you go, up to twice as strong. And then and then if you can also cold work it. So you get if you go sort of full hard cold work and do the final bit of cold work at cryogenic temperatures, you get outstanding strength properties, which are roughly equal to an advanced carbon fiber. And this is, and in our case for Starship, both the fuel and the oxygen are cryogenic, so this helps a lot. Whereas for Falcon 9, you use cryogenic oxygen, but kind of room temperature kerosene fuel. So anyway, we're both. This is quite a long explanation. Hopefully interesting. If both fuel and oxygen fuel and oxidizer are cryogenic, now you get the strength properties in the primary structure of both tanks, so both are very strong, very tough and resilient, also very easy to weld stainless steel. And we started off with stainless steel 301. That did have some fracture toughness issues at cryogenic temperatures. We switched to 304, and now we developed our own alloy, which is 30X, which is better than either 301 or 304. So Anyway, so now stainless steel only costs about $4 a kilogram. So we went from $130 a kilogram advanced carbon fiber to $4 a kilogram stainless steel, from 120 plies to 1 ply. It's just coil from the mill, and basically the same strength, and very high toughness and resilience. And don't even need to paint it, which is great. So paint is, paint on a big vehicle weighs many tons, and it's quite difficult to paint big things. So, but now there's another advantage. So, obviously, you can tell I'm a huge fan of stainless steel. Stainless steel, I should get a room or something.
Keep it going.
In making the vehicle reusable, so now it's coming in very hot. So the ship is coming in at hypersonic velocities, coming sort of kind of like a Mach 25 entry velocity. So this would just obviously just melt it, but if you've got steel, your melting point is much better, higher than aluminum, and you can handle much better temperatures than carbon fiber, because the resin tends to have problems. Like you can basically go, anything much above, say, 200 Celsius, or for carbon fiber or aluminum, is you start falling off a cliff from a strength standpoint. But for steel, you go 800, and it's fine. Even 1,000 can be fine.
Smaller TPS,
so
guys.
for the ship, this means that the heat shield mass is significantly reduced, because the heat shield mass is determined by the temperature on the back of the tile that then transmits to the hull. So if the hull is steel, you can have thin heat shield tiles, whereas if the hull is carbon fiber or aluminum, you have to have thick heat shield tiles. And you also need no heat shielding at all on the leeward side of the ship. So it is actually lighter than the most advanced carbon fiber vehicle.
Yeah, I'm very surprised at that, but that was very, very interesting. I appreciate your long disposition on this, and I thought that the steel substituting for aluminum on the reentry made some sort of sense. I didn't realize any of the other stuff.
Yeah, it ended up being the right thing, and then it's just it's the cost is ridiculously low. It's like $4 a kilogram. Even for the special alloy that we're developing, although it requires like a mill run, it's not using anything super exotic. We might throw a little exotic spicy something in there, but it's a small, it's going to be like 0.2%. So it's still going to be like maybe $4 a kilogram, maybe $4.50. And then it's just very easy to weld. Yeah, I love it. It's great. And then if we want to just add something to, if you want to, it's easy to repair. If you want to, add a sort of something to carry some wiring or plumbing or whatever, you can just weld it right on. It's super easy. It's great.
Thank you. I very much appreciate that.
It's a high tech, low tech. Wonderful. Yeah. Our next question will come from Howard Singer. Elon.
I like that guy. That guy was cool.
Hello. I started my science career watching Captain Video and reading Isaac Asimov, and you've made all that fiction real, so thank you very much. Mm-hmm. My question is, what are you doing for radiation protection for the crews? And if you have you explored the need for forecasts of the space weather conditions or the space weather
Good
environment?
Question, man.
Sure. Yeah. Well, I think there is, there's always some risk going into deep space, and we definitely wouldn't want to be traveling when there's like intense solar storms or anything like that. For going to the moon, like obviously, the United States has done that before, and it would be great to go back and great to have a permanent base where, if the costs are good enough, where we could have like a significant science contingent actually, on the base, permanently occupied. It would be epic. But once you're on the moon, of course, you're protected by the moon below you, and then you can put a lot of lunar regolith on top of whatever the research station roof would be. So once you're there, easy to protect. On the way, we'll have to check the weather report. And for Mars, it's going to be trickier. Obviously we don't have all the answers here, but and there may be some clever ways to reduce radiation effects, but I don't think they're insurmountable.
Alrighty, thanks. Our next question comes from Margie Kivelson.
So I'm an enthusiast for the outer planets, and SpaceX is giving the Europa Clipper a lift out to Jupiter. I wondered if you have comments on other missions that you would like to enhance by providing big lifts.
Sure. Actually, we're really excited and honored to be flying the Clipper mission. I think there could be some incredibly exciting things to discover. Hopefully, are under Europa. It seems like probably the best place for some strange life. So hopefully, we find some really cool things. So yeah, I can't wait to launch the Clipper, and that'll be on a Falcon Heavy currently. With the Starship, we could, the great thing about Starship is it really should enable us to send very big things, and also to send them fast, and need much less in the way of sort of planetary gravity assists and that kind of thing. Especially if we could build a propellant generation on the moon, then we could really send something with very high delta V. And if we have a base on Mars with high delta V, now you can basically planet hop from Mars to maybe Ceres, to maybe one of the moons of Jupiter, and ultimately all the way to the outer solar system. Basically, any place we can put the gas station, that gives us another whole leap forward. Ultimately, Starship is designed to be a generalized transport mechanism for the greater solar system, and so it's really whatever you can imagine being. If you could get 100-ton object to the surface of Europa, there's a lot more you can do than with a smaller object. I think it's very exciting. Obviously, we still have a lot to prove, but architecturally, it is capable of transporting kind of almost any arbitrary mass to any solid surface in the solar system.
Wow, terrific. Thanks. And Margie is actually leading the team building the magnetometer that you will be taking to Europa on the Clipper.
Cool.
Our next question comes from Steve Mackwell.
Hi, Elon. Thanks so much for your presentation. I was wondering, what are your kind of plans for humans to Mars in terms of timescales, and are you going to send folks there for kind of a shorter stay, or you think a longer stay and bring them back, at least initially?
I'm not sure. I think so. The first thing we'd want to do is confirm that we can land the ship safely on Mars, and so that might be, we'd want to probably land 2 or 3, I think, before sending people, and just confirm that we can land safely. And actually on those missions, we could obviously put a lot of scientific instrumentation. I would recommend putting the lower cost scientific mission stuff on the first mission, but we'll certainly have propulsive landing very reliable on Earth, as we've been able to achieve with the Falcon 9 booster. It's now, knock on wood, so it's no longer, it's quite normal for the rocket to land safely.
Wicked.
And we'll do the same with Starship. And then I'm not sure quite what would happen. I mean, we might be working with NASA or maybe NASA and other other countries to send people to Mars. But I view this very much as what sort of actions can we take that maximize the probability that the future is good for civilization? What are sort of like civilizational risks that we can potentially mitigate? I just think being a multi-planet species is a tremendous risk mitigation for human civilization. As we know, eventually the Earth will become, if you wait long enough, Earth will become uninhabitable. So in the long run, we're obviously all dead. but I think the technology that we develop in traveling from Earth to Mars, I think will be just a very powerful forcing function for the improvement of space transport. Like the initial boats that crossed the Atlantic and crossed the Pacific back in the sailing days were really terrible. They would often just plain sink. Once there was a reason to do large amounts of ocean trade, the sailing ships, the wooden sailing ships, got dramatically better. But you kind of have to have that forcing function. So that's what I think will happen. And we'll get much better at space transport. And I think this will also be very important if there's like a potential Earth collision event from some comet or something like that. The asteroids we can predict fairly well, obviously, but there's this massive cloud of comets out there that we don't know the situation. And they come in pretty fast. So there's always some risk of a comet like taking out a continent. There's this place like they talk a lot about extinction events where almost all life was destroyed on Earth, but they don't talk that much about the ones where, well, it was just a continent. There's plenty of sort of continent level extinction events that have occurred in the fossil record, and they're like really so common as to really not really generate much attention.
I know what you mean.
But if we've got large rockets that could potentially do something about that, then that could be, that could at one day save billions of people. But we've got to have big rockets and much more advanced space technology in order to protect against a comet coming in from far away.
Okay, thank you so much.
Terrific. Thanks, Elon. Our next question will come from Harlan Spence.
Elon, thank you for sharing your time and your vision with us. I had a question about looking back the history of exploration, human exploration, as we ventured from one place to another. Scientific discovery has always been an element of that, and you've shared a little bit about some opportunities there. But I was hoping you could share a little bit more. When you think about the aspects of scientific discovery that will accompany becoming a multi-planet species, what are the kinds of things that you're thinking about in terms of what we would discover along the way?
These are great questions.
Well, I think being able to really, have heavy-duty science research on the moon and on Mars, where you could really just go anywhere you want, drill core samples anywhere you want. I think we'd learn a tremendous amount as compared to having to send fairly small vehicles with limited scientific instrumentation, which is what we currently do for Mars and the Moon. So just having people there who can dynamically decide what they're going to do, and really being able to analyze the whole history of the planet, I think we'll learn a tremendous amount. And that would obviously extend over time through at least the greater solar system. I studied physics because I was just trying to find out what's the universe all about? How does it work? Where did it come from? Why are we here? I actually kind of got sort of depressed at one point because I was like, man, there's doesn't seem to be any meaning to life. It just seems to be like, and then I made the mistake of like reading the German philosophers as a teenager. That made it was quite depressing. But then I read Douglas Adams' Hitchhiker's Guide to the Galaxy, which is really a book in philosophy, disguised as humor. And he makes the point that the question is harder than the answer, and really basically the answer is the universe, and we kind of need to figure out like what questions to ask about the answer to that is the universe. And that's the question is the hard part, and then the answer is easier by comparison. So I'm like, I don't know, like why are we here? How do we get here? Is this real? Is this is this simulation or something? At least if we go to these other planets, we'll make the simulators work harder and have to buy more computers to run the simulation or something.
What the?
Yeah, I mean, I think it's and if we are able to at least be like a multi-planet species within the our solar system, then then hopefully we can develop the technology to send probes to other star systems, and eventually maybe send people, although that's tough, but we can certainly send robots to robot probes to all the nearby star systems, and try to figure out what's the meaning of life and what's going on, and are there any aliens out there? Where are the aliens? They're so soft.
Thank you, Elon.
Sorry, go ahead.
Do you have time for a question or two more?
Yeah, as much time as you like.
Oh, wonderful. All right. I do have one question from a board chair.
I don't want to know,
and
monkey.
it's this. One aspect of SpaceX that has distinguished it from the previous organizations has been its willingness to embrace failure as a development tool. When do you think you will be able to start selling Starship launches at prices significantly less expensive than Falcon 9, say 5 to 10 times less?
Oh God, these questions are dope.
Sure.
Yes.
Actually, I think it's not that far away. I think probably 2 years from now. Our rate of progress on Starship is very rapid, and like you said, we're actually getting ready to do our first orbital launch attempt within the next few months. We're expecting our license approval from the FAA around the end of this year, and so that probably means a launch attempt in January or perhaps February. And then
he'll talk about it.
We're actually building the factory to make lots of Starships and make lots of engines in parallel. So there will be many vehicles. The engine build rate is currently the biggest constraint on how many vehicles we can make, because there are currently 29 engines on the booster, and there will be 33 even at a higher thrust level. So that means so 33 engines per booster, and these are big engines. These are the Raptor 2 is a roughly 240-ton thrust engine. So we're talking like 500,000 or 600,000 pound thrust engines. So really quite intense.
That's awesome. It's so ridiculous.
In fact, I'd say that building the production system for Starship is much harder than the design of the Starship itself. But we have that in progress, and we intend to do hopefully a dozen launches next year, maybe more. And if we're successful with it being fully reusable, it means that we build up the fleet, just as we are with the Falcon 9 and the Falcon 9 booster, which is reused. We lose the upper stage every time, but we almost always recover the booster. So
of Starships?
So basically, we intend to complete like the test flight program next year, which means that it's probably ready for
I long for combat
for valuable payloads that are not kind of in the test, not for testing basically, but actual real payloads in 2023. So quite soon.
Great, thank you so much.
Holy shit.
All right.
Next question from Ned Wright.
Ned, keep it going.
Ned, I think you're still muted.
Ned! No! Okay.
Won't we all be glad when we don't say that all the time?
Ned, come back!
You have to preserve cryogenic propellant for 6 to 8 months to actually be able to land on Mars. And so I wonder what your plan is for that.
Another good question.
The landing propellant for Mars would be in separate header tanks. So these would be spherical header tanks. For Mars, there would probably be they might be contained inside the main tanks, or they would be up in the cargo section, but well insulated. So you would obviously have to have extremely well insulated header tanks for landing that are not the main tanks. So that's what we'd have for Mars.
Great, thanks.
I can explain that one better later if you want.
Riza Wexler is the next question.
Riza, keep it going.
Yeah, so changing topic to something that's happening before we have the possibility to be a multi-planet species. I also study the universe, and I'm trying to understand how it works and how it got here. And as you know, the satellite constellations from Starlink and other sources are already having a huge impact on astronomical observations. And this is really going to significantly limit the science potential of the next generation of observatories if we don't have a course shift. So what role do you expect SpaceX to play in working with astronomers and regulatory agencies to mitigate this?
Well, SpaceX already works with regulatory agencies and with with the astronomers, generally what we see is the telescope that is perhaps most sensitive to this is Vera Rubin, and we work directly with the Vera Rubin team to make sure that their observations will not be affected by Starlink satellites. And my understanding is at this point they are comfortable that it will not be an interference for Vera Rubin. They have there's a slight risk of capacitive coupling between some of the sensors there, but which can create ambiguity. But we're confident that we can work around that.
Great, thanks. Our next question comes from John Karras.
Okay, John.
Hey, Elon, thanks for all your time today. Appreciate it.
Bring us back
Kind of going back to a prior question about long-term storage of cryogenics for whatever mission, but I realize, or I believe, that your architecture for Starship to go beyond low Earth orbit to go to the moon has, cryofluid transfers and things like that, and long-term cryofluid storage, low boil off.
Oh, yeah, those not easy problems.
And so not easy problems. So the question I have for you is what are your plans to mature that technology, but before you have to rely on it to go to the moon, like in a year or two?
John, yes.
Well,
yes.
Yeah. So, there's a lot of ways to address it. By having launching one vehicle that is very well insulated, but does not return to Earth, effectively a propellant depot. So if you take a Starship, and you take the heat shielding off and replace that with thermal insulation, like a multi-layer insulation that's just very, very good at keeping things cold, then you could have one ship up there that it effectively just turns into a propellant depot, and then you send tankers up there to dock and transfer propellant. And so it should be able to be there for a while, and then whatever ship you want to go to the moon, you go up and dock with the depot, transfer propellant, and off you go. So that's a rough plan. We're pretty good at docking at this point. We've docked with the space station a couple dozen times, and the space station is a very difficult thing to dock with because we don't control both sides of it, so that is very challenging docking. Whereas docking with our own vehicle is comparatively easier.
Yeah, but both of these technologies have really only been demonstrated on very, very small scale. So your scale is a lot larger, and I think poses other problems. So good luck in solving those.
Yeah, no, I don't think we'll just sort of like, it's not exactly a walk in the park. So I think this is hard, but it is necessary, and it's the only way, at least with that I'm familiar with current physics, to actually make things work. And then obviously, aerial refueling is used quite a lot with aircraft. And so this is, taking that concept and just doing it in orbit. So we know that success is one of the possible outcomes. We're not breaking any physics. Physics is the law and everything else is a recommendation. But just because it's at least in the set of possible success is at least in the set of possible outcomes.
These are great questions.
Thanks very much. Next question will come from Amanda Hendricks.
Come on, Amanda. Keep it going.
Hi there. So I'm a co-chair of the Committee on Planetary Protection, and our committee is concerned with preserving the validity of future astrobiological experiments on Mars and other places in the solar system.
Yep.
Searches for life, extinct or extant. And I wonder if you can comment on SpaceX's planetary protection plans for Mars.
Sure. Well, first of all, it's not like we'll be launching to Mars really soon. Mars is a ways off, and but there is
it's funny.
Fundamentally, a choice to be made, which is, are we going to try to be a multi-planet species? Which would mean like at least in one spot on Mars that there is human biology, like that we will be, we're pretty hard to avoid no biology if you send humans there. We're biological creatures. But I don't think this is going to invalidate research on the rest of the planet. I mean, Mars is a big planet, and so and there've been rocks that have been knocked off of Earth and landed on Mars and that kind of thing. So, but yeah, I think you wouldn't want to sort of spread biological debris all over Mars, but I think we will have to put it at least somewhere if there are people going there, at least in one spot, and then just make sure we try to contain that and not have it sort of spread around. Yeah, and I guess it's same for the moon and other places.
Thanks. Thank you, Elon. We'll just take a question or two more. Next question from Larry Paxton.
Yeah, no, Morrison, it was pretty
Hi,
good.
thanks for your time. I have a question that was engendered by a remark you made in passing that I think is very interesting, which is where you said that there's a window of opportunity for us to get off the planet. And the question that occurred to me was, you followed it up with saying that you didn't know how long that window of opportunity would be open.
Yeah.
And you mentioned in passing, of course, the traditional things like, exogenous forces like cometary impact or a near-Earth object.
ASAT
But
question.
I was wondering, with all these compelling reasons for us to get off the planet, and including the compelling reason to have another refuge for the human race, what do you see as the biggest threats? And in particular, we have a wide range of expertise here. We've been talking about some of the problems that we think are the most important that are unresolved yet. I just wonder what you felt were the most important issues for us as a human race.
He green screened all the books behind him.
Yeah, I mean, in general, I've thought about this quite a lot, which is not to say that I've thought about it correctly, but I've thought about it a lot. And the one of the bigger risks on Earth would be, that we need to transition to sustainable energy. Even if one discounts the CO2 capacity of the oceans and atmosphere, eventually we will run out of hydrocarbons to burn, and so we need something that's long-term sustainable. So that's sort of I kind of split my time between Tesla and SpaceX, and so Tesla's trying to accelerate the advent of sustainable energy, and that's to mitigate the risk on Earth. And then SpaceX is intended to mitigate like longer term risks
Yes,
that could potentially extinguish consciousness as we know it. I mean, we got the sort of delicate candle of consciousness sort of flickering in the darkness here. And I don't know if you guys have seen any evidence of aliens, but I sure haven't. I get asked that a lot. So, I mean, I think the Fermi paradox is just an incredibly interesting question. And I'm not sure who said it, but there appear to be, if there's either a lot of aliens or none, and equally, those answers are equally terrifying.
Plot twist, he's the alien.
So, anyway, so I think, but with respect to nearer term risks on Earth, obviously sustainable energy and potential nonlinearities in the CO2 ppm in the atmosphere are a concern. If we start doing things like melting the Siberian tundra and that kind of thing. I'm probably less alarmist than most on climate change. I'd put myself in the moderate category on climate change. I just think it's the amount of inertia associated with the hydrocarbon economy is so gigantic that it will require a long time to make that transition. And so it's probably better to start it sooner rather than later. And that's why I describe fundamental good of Tesla as the degree to which it accelerates the advent of sustainable energy. It will happen, I think, anyway, but faster is better. Then, as for risks on Earth, I mean, there's always good old nuclear Armageddon. That's still one of the things. That's not out of the question. There's still a lot of nuclear missiles pointed at us in the U.S. and many parts of the world. I don't know what quite that risk is, but it's not zero. I think there's maybe some counterintuitive risks or that people don't put that much attention on. If you look at the birth rate trends, the birth rate trends are very negative. And so, and in many countries are seeing population decline with no end in sight. So I think there's, I think the very low birth rate, I think, is actually quite a significant risk, but an underappreciated one. So, yeah. And for population prediction, I would recommend taking things like the number of babies born last year and just multiplying that by the probable lifespan. And if you do that, I think you'll see numbers that are very, very bad for future population, and with an inverted demographic pyramid. So you've got a lot more older people, and then fewer middle-aged people, and then eventually just very few youngsters. And this will necessarily lead to resources being applied to taking care of the elderly instead of advancing science or advancing civilization. I'm quite worried about that one because I see no reversal of the trend. That would, civilization will die with a bang or a whimper. That would be dying with a whimper. Then there's obviously, of course, a pandemic that's like COVID, but which has a much higher mortality, sort of a long, high contagion, highly contagious, long incubation period, high mortality type of pandemic. That's clearly a risk. AI
advice
is, I think, maybe more of a risk than people realize. Ironically, the smart people tend to think AI is less of a risk because they think that they're so smart, but actually we're just humans and we're quite dumb. It's amazing we got this far, frankly. So if you see the advancement of AI, it's clear that AI will exceed human intelligence in every way if these trends continue. And the list of things that the human mind can do better than AI is less and less every year. So, hopefully that AI is coupled to human will, but it might not be. The the long-term goal of Neuralink is to achieve sort of better symbiosis with AI and with the kind of human mind. In the short term, Neuralink, I think, will help solve a lot of brain injuries and diseases and spinal injuries and that kind of thing. But long term, because one of the things that I'm getting quite esoteric here, but we're already a cyborg, really, in the sense that our phones and computers are an extension of ourselves, and you could say we arguably have sort of the primitive kind of limbic system, the cortex, the higher thinking, and then we've got a tertiary layer, which is silicon in the form of our computers and phones and everything. We have already somewhat merged with computers, but the issue we have is the communication rate. The bandwidth with the computers is low, especially output. If our output is 2 thumbs, that's we're talking maybe 10 bits per second or something like that. Or maybe 100 best case. So it's a very slow output.
More thumbs?
And as the intelligence of the computer grows, if that communication link remains very tiny, I think we will necessarily decouple from computers just because our rate of communication is very slow. And so if we can solve the I/O bandwidth question and by increase it by 1,000 or more, maybe 1 million, then you could have human machine symbiosis that is much better. I mean, that's at least one approach. Let's see, what else is there?
Chat, learn to type faster. Elon says it, okay?
I mean, religious extremism, if that becomes, if that grows over time, religious extremism is certainly a threat to advancement of science. So depending on how far that goes, that could be an issue.
We're just kicking over a bunch of rocks today, huh?
I will only add, I think that this is a fundamental question because, as you said, the Fermi paradox, there should either be a tremendous number of alien civilizations, or there is some gate that so many civilizations have failed to get past. And the question is, are we going to fail to get past that gate as well?
The great filters. Yeah. So I think at least one of the great filters is, does a civilization become multiplanetary or not? Because if a civilization does not become multiplanetary, then eventually the sun's going to expand and boil the ocean, and that's game over. So, and actually, if you think about it from a percentage standpoint, if Earth's been around 4.5 billion years, then it took us 4.5 billion years to get this far. It may be as soon as another 500 million years, and the sun might have expanded enough by that time to boil the oceans, potentially. If it's not 500 million years, it's not much beyond that. Which is basically means that if it took 10% longer for civilization to evolve, it would never have evolved.
Right. So there's an interesting one. Elon, do you have time for one more question? Wonderful. All right. Jill Dahlberg, please.
So let me just say, I feel lucky that you are here. So thank you. And not just here in our panel. You're very inspiring. My question is mundane. You're going to have these rockets. They're going to go up and they're going to go to 2 places that are going to need energy. The Earth needs a lot of energy as well. Yeah. So what are your plans for making energy? I'm thinking space-based solar power or something like that. Does your company have plans for proliferating energy systems you're going to need?
I mean,
well, Tesla does do solar power, and solar is actually, there's quite an amazing amount of energy that reaches us from the sun. Really, when you think about it, Earth is almost entirely solar powered. If it were not for the sun, we would be a frozen dark ice ball at 3 degrees Kelvin. So apart, keeping us warm and not super cold and frozen and dark is pretty helpful. And then almost the entire ecosystem is solar powered. Okay. Plants are a solar powered chemical reaction, and Apart from chemotrophs at the bottom of the ocean, it's basically, everything's solar powered. So we're really talking about just like a little bit of incremental power from the sun being used to power civilization. As a sort of good rule of thumb is because you get about a kilowatt per square meter of solar energy. So that then in a square kilometer, there's 1 million square meters. So now you've got a gigawatt of solar energy per square kilometer. And so if you've got like 25% efficient panels and there are maybe 80% of the area is, panel of then you've got like basically 200 megawatts per square kilometer of solar power. And so then if you say, well, okay, how much, then you really won't need a very large area to power the entire United States with solar. Like a little corner of Utah or Texas, obviously you prefer it to be distributed, but you can just say like, okay, how much is actually needed to power the US? And it's, somewhere between a square that's roughly 150 to 200 kilometers on a side will power the entire United States. So it's really clearly no problem to power civilization with with solar. And then of course there's wind, and I'm actually pro nuclear, fission wise, and there's also hydro and geothermal. So I think we will solve Earth's energy needs, and they are being solved. If you look at the growth of wind power and solar power, it's really has a very high growth rate. It needs to be paired with batteries in order to, because the intermittency of wind and solar. But the combination of solar plus battery can completely solve all of Earth's energy needs. In fact, for satellites that are in orbit, that's all they use is solar panels and a battery. And what is Earth but a large satellite? Sorry, I think you're on mute.
Do you want to follow up?
Yeah, I was thinking something more grandiose, like a space-based solar power system, but you have a good argument. You would just use solar on Earth, battery, and plethrate. I like that. Thank you.
It works great. Because if we think civilization uses a lot of energy, but it's actually very tiny compared to the amount of solar energy that reaches the Earth every day. It's just there. I get asked a lot about fusion, and in my opinion, if you just make a very large thing of magnetically confined fusion, you could absolutely make it work. I don't think any really major breakthroughs needed to make fusion work, but I think it's unnecessary to make fusion work because we've got a giant fusion reactor in the sky that just shows up every day and doesn't require any maintenance. So it's a low maintenance fusion reactor that shows up every day. So if we just catch the energy from, catch it, it's just keep lobbing all this energy at us, just catch it with the photovoltaics and store it in the batteries, and that'll solve for everything basically. We need a lot of batteries, but there's also, like the next question might be, do we face some materials limitation with batteries? And the answer is definitely not. I think the vast majority of stationary storage will use an iron cathode lithium-ion battery. So there's obviously plenty of iron on Earth, no shortage of iron. There's also no shortage of lithium. Lithium is extremely common on Earth. It's basically everywhere. So if you have basically an iron phosphate cathode with a graphite anode, and lithium carbonate, there's enough of that on Earth to power many civilizations. Several, or easily order of magnitude larger civilization than ourselves could be powered with the batteries with the battery materials that are readily available. So I don't want to suggest complacency here, but just that there is a very clear path to a sustainable energy future.
Okay, that's wonderful. Elon, we just want to thank you so much. The National Academy of Sciences is so pleased to have you here with us today. Paul Worcester is a member of the Space Studies Board, and this is also the Board on Physics and Astronomy. And just thank you so much for the time and the interaction with our members. And answering so many questions so graciously. I know it's past the 7 p.m. hour on the East Coast or wherever you are.
No problem. Thank you for the great questions, and it was an honor to speak to everyone. Thank you.
Thank you
from all of us.
Thank you.
I'll clap. I'll clap.
Cool.
I'll do it. Yep. I'll be that guy that claps on the Zoom call. I don't care. Yep. I'll be that guy. That's fine. So that was Elon Musk's kind of Q&A with the National Academy of Sciences, the board of the National Academy of Sciences. Dude, there were some really good questions in there. I was like super pumped that there were some good questions there. And dude, you hear what Elon said at the end? He's like, yeah, I'll take all the time in the world if you're asking good questions. He's like, thank you for the good questions, right? Dude, if you ask him good questions, he'll stay there for longer. Man, oh, that's so cool, dude. There was some good stuff in there. Also, cats. I mean, it's the internet, so there has to be cats. No exceptions. But what about the poop at Burning Man? Yeah, right. And the cat almost made him lose it. Yeah, dude, he was like, don't, keep going. Oh, man. See, that's good, man. There were some really good questions. Yeah, Flykin, we'll get it in. Even if it bumps after hours a little bit, we'll get it in. It's no problem. So my question is, how do you deal with battery degradation over time? I don't know, Tron. I guess invent a better battery. I've always said it, guys. Tesla's not a car company. They're a battery company masquerading as a car company. You hear what he said about batteries? Batteries are the key to sustaining the future because we have great ways to generate power. We have terrible ways to store power. Well, Tesla's just a front to mass produce batteries. Like, not a front. That's not the right way to say it, but it's true. Beam power, like, I mean, yeah, he did. Elon said, nah, don't need beamed power. I mean, he brought up a good point. Pursuing fusion would be good, but we already have that. That's not a bad way to put it. And, one of those other things that kind of clicked is, like, the Earth's already solar powered. The trees are solar powered. I'm like, yeah, I guess they are. I mean, there's other things, obviously, right? Photosynthesis. Rover stare down. What's that, Thomas? Remember that weekend we were Mars Road? Nice. Awesome. Yeah, pretty much, Gabe, yeah. We do have gravity batteries. We call them hydroelectric dams. Yep. Where electrical energy is not stored as electrical energy, but as potential energy in water that's under the force of gravity. Correct. Really good question, sir. But the way he fielded the questions is pure beauty. His way of simplified and truly difficult topic. Dude, I mean, Don, the way that guy's brain works, yeah, I could listen to him talk about whatever. He could talk about paint drying, and I'd just be like, Yep. And he'd probably find a way to explain it really well, In that regard, coal is solar power, yeah, right? Oh boy. Degradation is not that bad with software and thermal control. After end of life in cars, 10 plus years, it can go into grid storage, and after grid storage, the materials can be recycled into new batteries. Yep. Yeah. So there's something I didn't know. Elon said he read German philosophy as a kid, and that's what the reason I was like, if you're into philosophy at all, German philosophy is very real. Nietzsche is very, yeah, exactly, Buster. It's very real. Yeah, very real. The reason I was like, dude, you read that as a kid, is because, like, kids are already, like, cringy as frick, like, but a kid, like, reading Nietzsche, like, ooh, that'll mess you up as a kid, man. It's like, like borderline traumatizing, you know? German, it's like, German philosophy is very real. It's very, very real. Like Jung and Nietzsche and Freud, stuff like that. It's very real. Yeah, you probably don't want to read that as a kid. Want to show last. Not really. What is this? Oh, the energy tower. Yeah, cool. Hey, Mile, 13-month resub. Thank you. Hey, Freud is Austrian. Yeah, okay, fair. Okay, Germanic philosophy. How's that? That better? I liked it as a child. You can really tell that had an influence on him, Smoke. The way he looks at problems is very... It's like Carl Jung. Yeah, it's very, very real. Like, we gotta, like, that's, yeah, you could, you know, now that I'm thinking about it, it actually makes a lot of sense. Some sense, yeah, exactly. It's pronounced Nietzsche, by the way. Yeah, I'll just keep saying it the way I like it, Kevis. It's fine. Porsche. Are you pissed? Are you pissed? When I joined engineering school, most of the other kids in my class were reading Nietzsche. They were definitely a bit more mirthless. Yeah, no, yeah, Eater, it's... Nietzsche's like a book about when keeping it real goes wrong. Like that. It's very real. Be real, son. Be real, son. I gotta try to kill my father! You know? Like... What do you know about Jung? Not much more than anybody else that has a basic understanding of it. You know what I mean? Or it resonated with his personality. Yeah, maybe Endo. Something like that. But yeah, hey Max, 62-month resub. Recommended book to read from Nietzsche? Ooh, Vulcan, it's good to spread the word, though. Look, I have said, you know, people were saying, oh, he's already said this before. Dudes, you guys don't mind when I say the same thing to somebody new that has questions? Like I said, before the meeting, dude, like, and I'll get back to you on the Nietzsche stuff. I don't remember the freaking things. I don't remember what his books are called. Now I look like a dork. But then again, I kind of am a dork, so it kind of works out. It's important to show this stuff off because, I mean, dude, like, I don't mean to just be a freaking parrot here, but the vast majority of the stuff that he says, I absolutely 100% agree with. And that's like Starship and how it should work and, you know, using stainless steel, using simpler materials that are economical and actually better at, like, what Starship is designed to do, I basically agree with 100%. Like, you know, put the Germans on blast. That's right. Do you know how many times I've learned about retrograde propulsion? Exactly. Supersonic retro propulsion. Hey, it's cool to mention every time, guys, and sometimes that means doing the same explanation over. I mean, don't get me wrong. If you ask me questions, I try to get to know my chat a little bit so I can tailor responses to certain viewers. So, like, for instance, if somebody here is a race car driver and they ask questions, I will tailor a response centered around cars that helps people understand stuff better, or airplanes, or boats, or bikes. You know, like, take your pick. You know. Didn't Elon say Tesla's working on new battery tech beyond lithium that will not degrade as fast? The 4670 cells, yeah. Bikes. Do robots count? I guess. I mean, The only thing for me that I doubted is the time frame, because Elon time go burr. See, Vulcan, well, okay. I get it, ha 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 ha, Elon time. But Elon has said, okay, so consider this, dude, right? Everyone's like, oh, you know, January, yeah, that's going to happen, yeah, right? What else is SpaceX doing right now other than preparing for the orbital flight? What else are they doing? What else have they been doing since August? Nothing. Elon has said that the only thing that's keeping them from launching into space is regulatory approval from the FAA's programmatic environmental assessment. So, yeah, Elon time, I get it. But I don't think that stuttering. I think that people aren't taking that into account. Haha, Elon time. I said yesterday, dude, when we were looking at Starship, the floodgates are going to open. When that programmatic environmental assessment goes through, floodgates are going to open. SpaceX is going to have like 2 or 3 orbital flights on tap in the first like 2 quarters of 2022. Quote me on that one. And if I'm wrong, I'll admit it. But I'm just looking at how this all comes together. The pad's going to be finished in a month. The pad's going to be finished, and that's obviously your bottleneck. You can't launch without the launch pad. Kind of need that. I think that Elon time doesn't necessarily apply here because FAA government time applies here. And the only, Elon Musk's deadlines, government deadlines, one's a little bit slower than the other. So if you think about overall, right, basically the FAA goes slower than Elon. The FAA is slower than Elon time by a significant margin, right? Like there you go. Then you're ignoring the fact that they've been doing a ton of work with the OLP after installing all the systems on the table. We both know how much goes into GSC and how much integration hell will go into the first flights. So, what? So Vulcan, you're telling me that because they're putting a lot of work on, they're putting all the work into the orbital launch platform right now, that they're not going to get it done quicker? I'm confused. Oh, I'm not going to eat my hat. God, no, I like my hat. You lost me, Vulcan. I'm confused. Ship 22's common bulkhead section has RCS thrusters on it. Interesting, Thomas. Huh. It hasn't been nothing going on, like you said at one point. The FAA timeframe hasn't limited them necessarily. Maybe I didn't explain what I meant good enough. What I'm saying is that this downtime that the FAA is imposing on them is allowing them to get stuff done faster. It's single track stuff, so they're only working on the pad, and they're only working on Booster 4, and they're only working on Ship 20. That, comparatively to say the FAA just said, yeah, screw it, launch whatever. They probably would have attempted an orbital flight, and then Elon time what I'm saying is the FAA is the variable here. People say, Elon says, launch in January or February, and everyone's like, haha, Elon time. No. What I'm saying is that FAA time is tantamount to Elon time. So Elon time has a modifier in it here. If you think about like a universal Elon time equation, there's a variable in there. That variable is the FAA, and the FAA will slow down the entire thing to where the point where Elon's projections are actually making sense. You see what I'm talking about? That's a weird way to explain it, but still confused on how most of the equipment survives without directly the exhaust better. Foz, stainless steel. He explained it. Stainless steel. Super heavy. Okay, all right. Elon's thoughts about stainless steel and space. Let's not just say Elon. SpaceX's thoughts about stainless steel are genius. That's really freaking smart. Stainless steel, it might be heavier. So like if you have like a cubic centimeter of stainless and you have a cubic centimeter of aluminum, right? The aluminum's going to be lighter, right? It's going to be less mass. There's less stuff here, right? But the stainless steel can withstand a lot more heat than the aluminum. So the Starship stainless steel is part of its thermal protection system, and it's also part of the hull. Now, so that means with Starship, you need a smaller tile. You don't need as thick of a tile, and stainless steel, even though it's heavier, right, with the cilia fibers and the tough rock tile, tough and unifibrous reinforced oxidation resistant carbon composite tiles, the tough rock tiles, it's actually lighter than aluminum with a liner on it and glue and larger tiles, which is right. That's correct. Obviously, right? It's just physics, right? The SSTO will launch after Rocket Lab's launch. I correctly assumed that we were going to start talking about Starship after this, right? So now how does that pertain to the first stage? What does that have to do with anything? Well, the first stage, right? First stage is also made out of stainless steel. It's made out of the same thing. So it already has, the stainless steel is the thermal protection system on the first stage, so it does not need to do supersonic retropropulsion, which is a shame because that's my favorite. It doesn't need to. You don't need to do that. First stage doesn't need tiles on it. It's not coming back from orbital velocity. Because it's stainless steel, it doesn't need that. It's just, the stainless steel is the TPS. Simple. See what I'm saying? There's more companies that have stainless in rockets. One in Germany had stainless in their design around the same time SpaceX switched from carbon to stainless steel. Okay. I have the Rocket Lab thread up, Smirks. Yeah, I have it up. We'll talk about that after Starship stuff. Makes me wonder if the space shuttle could, in theory, be improved by using stainless steel. Starship is Space Shuttle 2.0, Nighthound. There's no way that SpaceX didn't look at the space shuttle when they considered Starship. There's no freaking way, you know? Helicopter is airborne and en route to the recovery zone. Nice. Dream Chaser Shuttle 2.0. Okay. Think about it. So, hopefully that makes sense. The stainless steel is part of the thermal protection system on Starship, but it's also part of the hull. So with the first stage, Falcon 9 doesn't have a heat shield, but it uses its rocket engine as a heat shield because Falcon 9 is made out of aluminum. It has that same problem. It'll melt at a lower temperature. Aluminum is very good at conducting heat, too. That's the other thing to take into account. It's very good at conducting heat. That's why cars' radiators are made out of aluminum, right? So they can exchange the heat better and conduct the heat and exchange it better with oncoming air, right? So Falcon 9 needs to blast the engines or else Falcon 9, it'll break up. Just like, 1061 or something? 1061 exploded during reentry because the supersonic retropropulsion didn't work correctly. It popped during reentry. They lost the first stage a little while back, right? Everybody kind of forgot about it, which is kind of funny. So with Super Heavy, you don't have that problem because the stainless steel is part of the thermal protection system, which is another thing that I don't think Elon even talked about. You know? There you go, Smirks. You'll get it. You'll get it. I wonder if they would still see the original benefits if they were going with carbon right now. Well, Pink, I think Elon covered that pretty sufficiently. I bet the experience gained since then reinforced the steel choice. Pink, without just parroting what Elon Musk said, so people just don't think I'm regurgitating what he says. I try to change up the stuff that he talks about and put it in my own words to show that I understand it. He talked about, carbon fiber, et cetera, and using cheaper materials, right? Not cheaper materials in terms of quality, less expensive stuff, right? Jock said it. There are other rockets that use stainless steel, right? Centaurs have been using stainless steel since 1962. The upper stage for the Atlas rocket. So Atlas Centaur, Atlas 1, Atlas 2, Atlas 2AS, Atlas 3, Atlas 5, all have stainless steel upper stages. But they're not reusable, obviously, right? But they all have stainless steel upper stages. But the idea of using materials that are easier to make, so not necessarily using like the most exotic, super lightweight material to maximize the Tsiolkovsky equation, right? You use dumber materials and you make a bigger rocket. Economies basically use something that's more common. Yeah, you take an efficiency hit, but it's easy to make, so you can make a lot of it. Sea Dragon is a good example of that. That's not the first time this has been proposed, right? Sea Dragon was supposed to be made out of marine grade steel. They were supposed to build that rocket in a dry dock that was designed to build aircraft carriers, right? So Robert Truax came up with that idea. It's not the first time that has been proposed. I would have thought that stainless steel is more exotic. I was wrong. It's steel. It's just a different type of steel. Raptor 3 has got to be way cheaper for way cheaper evolution for mass production. Yeah, for sure. Does that mean big spaceships like Forward Unto Dawn will be made out of ship-grade steel? Oh, Vorse. Now, why did you do that? What are you trying to do? It'll be entirely application-based. I don't know. How does marine-grade steel work in radiation? I don't see why why wouldn't you? If we could figure out an easy way to get the steel up there, yeah, of course, we'd probably manufacture stuff like the Expanse or like Halo or Battlestar Galactica. That's the difference between BSG, Star Trek. I mean, aside from Zephyr Cochrane, we don't have one of those. We don't have one of them. Their on-orbit manufacturing is way better than ours. Like, if we're comparing our real life to sci-fi, but you get the idea. Yet. Exactly, Dragon. We don't have one yet. Hey, there's plenty of Titan II missiles around, dude. Plenty of Titan II missiles. Speaking of the Expanse, have you seen the Season 6 trailer yet? Came out very recently. Negative. Yeah, in Halo they use Titanium A. That's right, username. Yeah, they're using titanium for ship manufacture on orbit, which... Man, I hope you found some titanium asteroid or something, because there's not enough titanium on Earth to make ships that big. Well, that's not entirely true. There probably is. I mean, and it is 500 years into the future, so... either one of those is plausible, so... So off topic, but could you use stainless steel to make a truck frame? Yes. Sawyer, of course you could. They're doing that with Cybertruck. Cybertruck? It's not about getting the steel up to space. It's about making steel from what's already up there. Yeah, Gagan, exactly. Yeah, you're right. It's better to use what you have up there, because getting stuff up out of Earth's grav well is a pain in the butt. I mean, once again, you talked about that. A DeLorean's not a DeLorean has a steel frame. A DeLorean has a steel frame with a fiberglass body with stainless steel over the fiberglass. Yeah. The only stainless steel that a DeLorean has on it is the outer skin. Fiberglass body, steel frame. It's actually, the steel frame's based off of a Lotus. It's a Lotus chassis, believe it or not. What's the space elevator in Satisfactory made out of? Unobtainium. Kind of forgot about Cybertruck, honestly. I mean, Sawyer, if you're talking about, like, if you took my truck, right, and you made the frame out of stainless steel, yeah, of course you could do that. Stainless steel's stronger. It'd be great if you live somewhere cold, because the frame would get really strong. Transparent aluminum for the win. I hope so, Salty. That'd be cool. Okay, Vanguard. GIF of this year's progress. Oh, that's cool. I mean, Sawyer, the big thing that the auto industry could do for trucks, it would be galvanize the steel that they make. But that's expensive. If you galvanize the steel, the truck basically never rusts. It would last forever. there's a reason why they don't do that, because they keep the cost down, and also you know, transparent aluminum already exists. Sapphire AL203. Oh, that's cool. Why aren't people using it for things then? I hear people talk about it all the time, caveman. If transparent aluminum's already a thing, people say, oh, it'd be great for an application with spaceflight. I honestly don't understand why, but what's the thing? If it's already been invented, why aren't people using it? Money. Okay. Sapphire is very expensive. Oh, okay. It's hard as hell, but prone to fracture. They use it in military vehicles. Neat. Interesting. So yeah, that was a cool meeting. I don't think we necessarily learned anything in particular, but yeah, it was still cool. I'm gonna turn the AC on. It's getting kind of warm in here. Yeah, sorry. I'm gonna hear a in the background, dudes. But what about Pokemon Sapphire? That's the real question here. Where we gotta ask the real questions. All right, so anybody have any other questions about that stuff? They were good conversations, really. I enjoy talking about this. Theory crafting about Starship is cool. I wanted to have a space news today about, like, theory crafting with Starship and where it could go, but Elon kept referring to Raptor 2. I think we'll see it way sooner than we think. Thoughts? Exists already, Smirks. Shh. Why is Starship not orange? Hey, that depot Starship that he was talking about, replacing the thermal protection system with spray-on foam insulation or something. Starship might end up orange. It would more likely be more like a Centaur, though, so it would probably be a white TPS on it. But it's a propellant thermal protection system, not a re-entry thermal protection system. They've tested it? It already exists, Smarks. Yeah. There's rumors going around that they've tested it already. And Elon did say on Twitter the other day that they got 1 to 300 bar for a sustained period of time. You can surmise from that Raptor 2 already exists. And yeah. Can we be real? We need a green Starship. I mean, it's kind of good. Galvanized frames suffer from issues of bolts and tapped holes being a major problem point. It introduces more corrosion opportunities than it prevents. GM found a wax of some kind is the best additive for frame corrosion prevention. Yes. Well, you definitely learned probes to Uranus might be a thing. They didn't say Uranus, they said Europa. Okay. So, I mean, pay attention next time. Jeez. 400 bar, yeah, I don't know. All I want is Centaur 5's refueling at Elon depots. Yeah, that'd be cool. You think SpaceX will eventually develop a large diameter Starship like 12 or 18 meter? Elon seems to be a kind of necessity kind of guy, Lundprod. I don't think they'd develop that unless they needed to develop that. You know what I mean? Can we do this for Friday Night Racing one time? Ride 4. Maybe. I don't know. I don't think people would be into it predominant, but ask around. Yeah, Europa has to stay away from Anus. Europa needs to not be near Uranus. Yeah, it's true. What do you think they'll fit 4 more engines in that cluster? The inner ring motor kit. Yeah. We've already seen it. So Booster 4 has a 9-engine cluster with 20 engines on the outside. All right. Booster 5 has an 11-engine cluster. Or no. A 13-engine cluster. Right? It's 13. 12 with 1 in the center. Yeah. Any new details on the new unnamed SpaceX engine from SpaceX? No, he didn't say anything about it in Belupa. And I thought that guy was going to ask an ASAT question, but he didn't, which was cool. Yeah. Yeah, the 13 inner ring has 3 in the center. You're right. Is it 3 in the center.com? Booster 7 or 8 will be the first one to get 33 engines. Yeah, so there's 3 in the center, right, with a ring of 10 and then a ring of 20, right? That's how it goes. I didn't remember. I did not remember that correctly. Seriously, stuff changes so damn fast. It's really, really tough to keep up with it. Yes, 3, 10, and 20. Yep. Cool. That was an awesome meeting, though. But, I mean, also, we have a rocket launch in about it. Well, it's about an hour. About an hour away. We could look at the Starship footage. I think we should do that. And then on the other side of the Rocket Lab launch, we're going to go to launch the SSTO. Yeah, Fossil, it makes perfect sense. Yep. You could show some stick rocket footage. What? Like this footage that I've been conveniently linked to from Space Scout? Vulcan, does that have anything to do with it? Here, we'll look at this real quick and we'll check, then we'll check out Starship footage. All right, let's see. What do you got? Yep. Top hat.
Auxiliary power units have started.
Stick rocket.
Solid rocket motor nozzle gimbal checks are underway. Ignition system is armed.
Let's see what we got. So this footage is Space Scout, a news outfit that hangs around in the stream and lurks, scavenges. You got this recently acquired footage here of Ares 1. So let's take a look.
Activated. T-minus 10, 9, 8, 7, 6, 5, 4, 3,
and liftoff.
1.
Ares 1X.
And ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Oh, this is like a full track then.
Altitude now 2 miles. Chamber pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory.
Ooh.
We passed Mach 1 and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2.
Yeah, okay,
now
that's
10
right.
miles altitude, downrange distance 8 miles, and a velocity of 1,500.
EJ, I just said sneak preview.
Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response.
That's cool. Sorry, I was just really into it. It's one of my favorite rockets.
And we started the last PTI maneuver, structural mode ID.
Water system is activated. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And And ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Nice. They're not bringing back Ares 1. This is just footage that's never been released before. The style of rocket in KSP is great in career mode. Yeah, Clydesdale first stage, yes.
Altitude now 2 miles.
All the times ramps are in the description.
Vapor pressure now tapering off as designed. Vehicle is aligned itself with
Man, that thing
planned
would have been
trajectory.
cool. We should. I will still say this. We should make this. We should still make this with a reusable on orbit upper stage. Dead serious.
We have our
No, it didn't almost hit the tower. It cooked it though. Yeah, it's a. So this is, guys, this is a concept rocket that was supposed to be for the Constellation program called Ares 1X. Ares 1X had was supposed to have a 5-segment solid rocket first stage. So it's one of the side boosters from SLS, and then a Hydrolox upper stage that was with a J2X engine. So like it's almost if you took like an Ariane 5 core stage from the European Ariane 5 and put that on top of a 5-segment SRB. Yeah, it's pretty hardcore, man. It's a pretty crazy rocket. This was the one test flight that they did before the program got canned. Yeah, and this is all footage that we haven't seen before. This was a launch in 2009. Yeah, that would be really good, demo. Yeah, that'd be really nice. What was the Starship presentation? It was Elon doing a Q&A at the National Academy of Sciences meeting. Why was it canned? Gek, you've heard me talk about $30 billion, etc., etc. Yeah, that's why it was canned. Because they rebaselined the cost of the Constellation program. Just like they rebaselined the cost of SLS the other day. It got Rule 8'd hard.
Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket
I don't think we've
design.
seen this angle before, Vulcan. Do you know that Ares 1X is part of Scott Minley's worst looking rockets list? Yeah, Scott doesn't like it. Yeah. So, guys, this is a 4-segment SRB. This was a dud test flight. The Ares 1X to the Constellation program is what Starhopper is to the to Starship. It kind of looks like what could be a thing sometime soon, but it's not. This is a 4-segment leftover shuttle SRB, and it has a dud. It has a dud 5th segment stacked on top of it. And the only thing that was really real about this from Ares 1 is the roll control thrusters and the inner stage. Up here, where the upper stage is supposed to be, that's just a mass simulator, and then it has a fake launch escape system on it and a fake mass simulator where the Orion capsule would be. Yeah, like I said, it's the Starhopper of Constellation. It really wasn't a full fidelity test. This is a hardcore boilerplate test. They were really trying to get the tumble motors to work right, amongst other things. They launched it on a shuttle's launch pad. And it ruined 39B. 39B was inoperable after this. But then again, this 39B was supposed to not. They were supposed to renovate it after this. They were going to take the whole thing apart. The idea with the Constellation program is that you'd take 39B and you'd destroy it after this, and then it would be ready in a couple of years to launch the real Ares 1, the Ares 1Y test. And then you'd launch routinely off of 39B with Ares 1, and then they'd take 39A and convert it for Ares 5, which was kind of like a SLS on steroids.
4, 3, 2, 1. Ignition and liftoff of Ares 1X.
Tumble motor
Testing
ignition.
Concepts for
Dizer, 33-month resub. Thank you.
Rocket design.
Is there a maximum to the amount of segments you could have? I'm sure there's some kind of physics limitation somewhere. We almost had Omega, but then Northrop Grumman bought OATK and NG has no... Yeah, that's not really how that panned out, Squish. You definitely want to see some onboard footage. Go to 27 minutes. Cool.
2, 1.
This is just footage that we really haven't seen before.
Liftoff of Ares 1X. Testing concepts for the future of new rocket design.
I mean, full launch test flight without people. I mean, the Constellation program was made as a response to the kind of mess-ups during the shuttle program. In fact, Constellation is a direct response to the Columbia disaster. Constellation was formed under the 2003-04 Vision for Space Exploration, which was a new space policy that was rolled out in response to STS-107. It was basically because of, you know, NASA learning their lessons, you know. Just wait till you get to see the integration footage we got. Should have that out later this week. Yeah. Yeah, Vulcan. I've never seen footage of it being put together, dude, but I know that there's basically a spiral staircase, so to speak, inside of the mass simulator upper stage. I've seen pictures. One of my buddies that watches the stream worked on Ares 1. He sent me pictures of it before. Pictures of all the segments being stacked and whatnot. Yeah. I've never seen footage of it, though. That's cool. That's entirely up to you, Vulcan. I don't want to waste your time. I want to see the onboard here.
10, 9, 8.
Yeah, see,
7,
it's the space shuttle's launch pad, but no
5,
space shuttle.
4, 3, 2, 1. Ignition and liftoff of Ares 1X.
Hello?
Testing concepts for the future of new rocket design.
It's kind of dizzying.
Altitude now 2 miles.
That was very quick to get up to 10,000 feet. Jesus. Let's go up here. What kind of G's does this thing pull? It was human rated, Van.
The last PTI maneuver, structural mode ID, and we passed T+1 hole.
Or was supposed to be human rated, so it wouldn't be any more G-forces than the shuttle.
Traveling Mach 4, 20 miles altitude, downrange distance 32 miles.
Yeah, you see the entire, the entire SRB is doing that.
Observed.
Lateral oscillations. Interesting.
Burnout.
What was the purpose of the tumble motor?
Down. CRDs have shut down. BDM fire.
No.
And SEP. We show a SEP and a tumble motor ignition.
So
and we can also
the tumble motor is there to get the SRB to spin. The reason why you want the SRBs to spin, is there's a number of reasons. One, they wanted the SRB descent profile because these things would have been reused during Constellation. They wanted the SRB descent profile to be basically exactly the same as the space shuttles. There's a couple of things, though, that people don't realize about the solid rocket motors, okay? One, solid rocket motors don't have any thermal protection system. They don't need it. They're made out of steel. Two, to basically make sure that the heat is evenly dispersed around the steel, the motors tumble through reentry, through what little reentry heating that they would get. They're not coming back from orbit. They're coming back from a high suborbital trajectory, right? Well, actually, it's relatively low for Earth orbit, but that doesn't matter. The second part is that the SRB really needs to end up nozzle facing towards the ground or towards the water. And if it just separated from Ares 1 and just kind of kept going, it would have ended up entering inner stage first towards the ground. The SRB doesn't have a rearward or forward center of mass bias. It's just kind of right in the center because it's just a tube, right? So, if you tumble the thing, right, you can pop a drogue chute at the right time and get the thing to stabilize out. Otherwise, there was really no way to get it to flip over. There's no attitude control system on this thing to get it to do what Falcon 9 does, where it turns around and comes back down, right? So the reason they did it is to make sure that the thing didn't get too cooked during reentry. Now, the other reason is you have to hit the water nozzle first. If you do not hit the water nozzle first, the SRB will break in more ways than one. The SRB acts as a gigantic pneumatic damper when it hits the water. So what does that mean? So the inside of the SRB is hollow, right? It's kind of like this, right? This is a Dragon replica, but it's kind of hollow. Now, if this thing hits the water like this, obviously it's just going to hit the water and it's going to bloop into the water, right? But if the SRB falls backwards into the water will go up the nozzle, right? And what that does is it traps air inside of this cavity, inside of the combustion chamber of the SRB. That's good for two reasons. One, the entire SRB works like a big shock absorber, so it absorbs the impact of the SRB hitting the water. This is why SRBs, I mean, even with the parachutes, the SRB's still hitting the water going 50, 60, 70 miles an hour. But when it dunks into the water, the air gets compressed inside of the SRB from the water coming in. It gets compressed to a point where eventually it absorbs most of the force of hitting the water. And that keeps the SRB intact. The second thing is that the SRB actually stays afloat. That air, I mean, it's not like the SRB isn't airtight, because if it wasn't airtight, SRB exhaust would come out the sides. They had a problem with that once, but not with these SRBs, right? So if it enters nozzle first, the air gets trapped there and it just kind of stays there. The SRBs float. They float just fine. Yeah. So you got to get him to tumble. Ares 1X was testing the tumble motors. See how it's kind of flipping around like if the SRB separated from the shuttle, right? And they would just twist around. The tumble motor was there to mimic that descent profile. That's how they prevent the SRB from bobbing back out of the water and falling over to destruction. Correct. Yep. That's right. Yeah, K-Mira, I have that open. If I have time, we'll get to that, but I don't think we have time today. What's this? What in the hell? So I can tell you right now, I've never seen this footage.
2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Never seen the upward footage before, Vulcan. Wait a minute. Let's see what happens when it gets to max Q. I saw the thumbnail.
Altitude now 2 miles.
Bro! Yo!
With the planned trajectory.
That's awesome!
We passed Mach 1, and we're now passing max Q.
Oh man, that's pretty cool.
Max Q system.
That's pretty freaking cool.
Engaged.
Oh, that's very Bing chilling.
Solid motor chamber pressure picking.
Dude.
T plus 62 seconds.
That was excellent. Here, let's get up here.
Tail off is observed.
That's a shock cone.
Burnout.
Actually, it's not really.
Shut down.
Is it a shock cone?
CRDs have shut down.
I always confuse that with the name that comes.
And SEP.
That happens
We show
with
a
rockets.
SEP and a tumble motor ignition. And we can also confirm on video
I think that's called a Prandtl-Meyer singularity, right? Right? Aerodynamicists, help me out.
See both parts of the vehicle.
The vapor
tumbling,
cone, yeah. That's, I always get shock cones and vapor cones
well
confused, but that's what it is. Sprinkles, you're right.
Successful separation. Good clean signal all
Hello.
the way.
Oh, hey, dud upper stage. Never mind.
190 seconds.
Whoa. Is this footage all the way down?
No. Liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Let's take a look. This footage was obtained from a Freedom of Information Act request by our buddies over at Space Scout, a space news outfit. Why did the paint start bubbling? It's not paint, it's condensation. At least I think. Hey, I don't hate this footage. I've never seen this view before. I didn't know that the booster had USA painted on the side either. Wow. That's really, really cool. What a cool rocket.
Plan trajectory. We passed Mach 1 and we're now passing Max Q.
Did they ever do drop tests of the boosters early in the shuttle program to see how the air cushion principle worked? Or did they just use STS-1 as a test? They probably did something. I don't know for sure though. I mean, that's not the first time that concept had been proposed. Damn, dude, what a great shot. Salaraith, 47-month resub.
Altitude, downrange distance 8 miles and velocity of 1,540 miles.
There you go, Jock. Thank you.
Plus 80 seconds. We've started our supersonic large amplitude ID maneuver PTI. We see the response.
This is big. We have confirmation that Boeing and NASA conspired to slow the development of the depot in space in order to help SLS. Yeah, sure. Sure they did.
Started the last PTI.
Sure they did.
Mode
yeah, I'm sure that's exactly how that played out.
We passed T+1 105 seconds. Vehicle's now traveling Mach 4.
Dude, that article's from a long time ago, Jack. What do you do? Where how did you? All right, Jack. How did you obtain that? Where did you get that? Was that like post you just looking for this? Or, I'm interested. I'm interested. Where did you find this? Like, how did you come across this article?
SRM tail-off is observed. Burnout.
You're just going through Twitter threads. Yep.
Our APUs have shut down. CRDs have shut down. Medium fire. And SEP. We show a SEP and a tumble motor ignition.
Auxiliary power units
Never seen this footage either.
Solid rocket motor.
Yeah, I'm not interested, Smirks. I debunked that article in 2019 when it came out.
Mission system is armed. Sounds 2, 1. Ignition and liftoff of Ares 1X.
Cool.
Testing concepts for the future of new rocket design.
All right, let's see what we got here.
Altitude now 2 miles. Vapor pressure now tapering off as designed. Vehicle is
yeah, I mean, goalie, Ares 1X and Ares 1, that design is as tall as SLS. It's 300-foot tall booster. It's 100 meters tall, guys. It's a big piece of equipment.
We have our Max Q system ID maneuver PTI engaged. Solid motor chamber pressure picking up again. T plus 62 seconds. Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response.
I guess this is also Eric Berger. No, George is not wrong, but never mind. Yeah. Obviously, George is wrong. That's not. You came here. You didn't read the article, did you?
PTI maneuvers,
It's
structural
fine.
mode ID, and we passed T+1 hold 105 seconds. Vehicle's now traveling Mach 4, 20 miles altitude, downrange distance 32 miles.
Ares 1 goalie, 25 metric tons, so about the same as a Delta 4 Heavy or an Atlas 551.
Burnout.
Actually, more than Atlas 551. Ares 1 was a pretty good vehicle by design. It could have had a pretty good job in the commercial markets, dude. Because the solid rock, the first stage is nothing. It's a bunch of solid rock. It's simple. It's got one moving part.
We see both parts of the vehicle tumbling.
I did it over 2 years ago and we had a heated discussion, and it's too late over here to start again. So why'd you bring it up again?
Good clean signal all the way. T+150 seconds.
Bro, cool. All right, here. Just because, here, look. You can make a pretty good fuel depot with a medium-sized rocket. You can make a really good depot with a super heavy lift rocket. That's the entire premise. That's it. And before you say, well, this guy seems to think so. That was the whole premise of that. Eric Berger just construed it to make ULA look stupid and Boeing look stupid. Big surprise. Upper level winds are approaching the limits as they get closer to T0. I hope they don't scrub. But then again, that would give me some leeway time here. I've never seen... Dude, look at that footage. That's crazy. Yeah, that's really cool, man. Oh, that's so sick. Yeah, it's burning off some residual there. You see that? It's cool because the SRB does a little bit of pulse jet stuff inadvertently there with burning off the residual solid fuel. Oh, that's so freaking cool, man. See? Look at that. You wanted it to tumble so it would make it through re-entry. Now, watch. You don't want it coming down interstage first. How would they have compensated for tail off? Pack the grain different. Pack the grain different. There's, okay, there we go. There's your drogue. That's nuts, dude. And it should, once it gets, you should see 3 chutes deploy here. One of them doesn't deploy all the way. And then right before it hits the ground, it pops off the nozzle. The nozzles on the SRBs are not reusable. There's your 3 drogues, or 3 main chutes. One of them popped. Yeah. Then it'll pop the nozzle off here in a second when it gets close to the ground. Oh man, those parachutes are riggedy wrecked, dude. Yeah. It didn't do... That thing didn't do the hydraulic thing that I was telling you guys about. It didn't do the hydraulic thing because one of the parachutes failed. Man. That's the Ares 1X booster got really messed up. It really broke. Yeah, that thing got really damaged during landing. Now you can see why. It's a 5-segment booster. The rigging couldn't handle the extra segment. So I'm frankly amazed that all the parachutes didn't fail. But one took the load while the other two survived. And look, that one partially failed. Holy crap, man. Yeah, see, it's not supposed to do that. The thing's supposed to go straight into the water. It ain't supposed to do that. It's supposed to go dunk in the water and then just kind of stay there or fall over. I mean, nah, it ain't supposed to do that. Would they fire the staging at separation or let the second stage coast for a few seconds? No, it would have looked like Falcon 9, Goalie, so separate and then ignite. Yeah, that's why that thing got all messed up, because of that parachute failure. And I'm hoping they've fixed that by now. Why? SLS's boost, they're not reusing them. Okay, Vulcan. They're not reusing SLS's boosters, guys. That's not a thing. There's no recovery ships, ironically. Duel, that was Ares 1X test. Yeah, fellas, the shuttle engines aren't all they're throwing into the... that's not all they're throwing into the ocean. SLS's SRBs are not being reused. Man, here's the integration footage. Yo. Bob and Doug could do it. They could. No, seriously, Goalie. Yeah, of course they could. Holy crap, stop doing that. Oh my god, that's giving... Dude, I am getting a little bit of anxiety from that. Yeah, there's your... That side panel. That side panel is where the attitude control, the roll control systems are. There's inside of the upper stage. See? There's just a bunch of service gantries in there. That was so they could integrate it without having a high bay configured. See, the idea is that if they were going to launch a mass simulator... Ow, that was my knee. If they're going to launch a mass simulator upper stage, why not put the service gantries for it inside as part of the mass simulator? Because it's going to take a second to reconfigure a high bay, right? It's going to take it like a year to do that. So this way you can do a little bit on the side of rapid prototyping, which not a bad idea. Yeah. I'd like to stand on those gantries during launch. Yeah. Yeah, this can't be NASA. Yeah, not NASA in this day and age. Doesn't SpaceX use the same but made out of wood? What? Constellation was supposed to basically put NASA on a course, kind of like SpaceX's, guys. Like, it was supposed to kind of bring back that that fighting spirit that NASA had during the Apollo program, because it was something new and exciting and going back to the moon, etc., etc. Yeah. That was the idea, at least. And one of the smartest things about the Constellation is that it's all shuttle-derived. Well, most of it is shuttle-derived hardware. So the idea is that you keep your technical expertise at NASA, something they tried to do with the SLS program, but it didn't happen. It never happened. Golly, yep. How did the Electron mission go? It's actually very soon. Yeah, Bram, like I said, dude, people are going to call me crabby. People say, like, oh, EJ, you're overreacting at this stuff, man. No, dude, NASA wasn't always like this. And it's annoying, because there was a time where NASA was like SpaceX, man. Like, pushing the envelope and stuff. Which blows, but, hey. Jim kind of righted the ship a little bit, and, you know, then, yeah, hey, let's see. Bill could right the ship, too. He can still right the ship. Solid rocket producers didn't have enough congressmen on your side. It wasn't Congress that had a problem with Constellation, guys. Yeah, it wasn't Congress that had a problem with it. Congress is actually fully for it. Both chambers of Congress, actually. Yeah, the executive branch didn't want to do it. And unfortunately, they're the one that controls NASA's the direction. Congress, on the other hand, controls the purse strings. So if you have an executive branch that doesn't want to do what Congress wants to do, you get a boondoggle. This is why deadlines and the direction of NASA is so ridiculously important, because you have to set expectations and go from there. You have to set clear, concise goals. That's why I think that's so vehemently important. Yeah, SLS had Constellation had full congressional support, guys. Both sides of the aisle. Yeah, everybody wanted to do it. Curious. When's KSP? On the other side of this Rocket Lab launch here. Careful. Need a lot of young blood to get back to the Ares 1X days. Yep. Well, all that young blood wants to work for SpaceX, dude. You know, like, what do you want? Rocket Lab to the moon. Well, they will go to the moon with the capstone mission for sure. Rocket Lab is a contracted payload from NASA to go to the moon. So Rocket Lab will, in fact, go to the moon. Hopefully in more ways than one. What? I love NASCAR. Yeah, I get you. That's the thing to say, right? Like, dude, not in here, man. You know. Not in here, my brother. Try to keep a little civil. Just a little bit. We're here for space, remember that. But yeah, I mean, once again, you're like the other thing, dude, is that I don't bring this up to point fingers. I'm not like Bill. I'm not like NASA. I don't point fingers at people. I bring this up as to show what the circumstances are in the past to basically tie one hand behind NASA's back and force them to fight with the other. You know what I mean? It's important to understand the criteria in which leads to program cancellation. That's the only reason I bring it up. I don't bring it up to point fingers. You know what I mean? Pointing fingers is stupid. It's a waste of time. You point stick rockets. Yeah, baby. Just got off work. What time is the launch? Launch is currently scheduled for 38 past the hour, so about 20 minutes. Here we go. Here we go. Yeah, that's right, man. I mean, but then, like I've always said, dude, I'm greedy. I'm greedy, bro. I want more. I want NASA to launch big stuff. I want SpaceX to launch big stuff. I want Rocket Lab to launch big stuff. I don't care. More rockets, the better. I'm greedy, bro. I'm greedy. Give me, I don't want one rocket. I want all the rockets! Do you think NASA will always train our astronauts, or could other organizations come forward? SpaceX is already training astronauts, but they're training astronauts how to fly Dragon, Wepler. What, I mean, yeah, I mean, explain Inspiration 4. Sure, absolutely. Love at first insight.
Hello from Rocket Lab's Mission Control Center, where we are bringing you a live look at the Electron rocket ready on the pad at Rocket Lab Launch Complex 1 in Mahia, New Zealand. Thank you for joining us this afternoon from Rocket Lab's 22nd Electron launch, a mission we have called Love at First Insight for our customer Black Sky through mission integration partner Spaceflight. I'm Muriel Baker here with you from our Mission Control Centre in Auckland, New Zealand. We are about 19 minutes away from the scheduled launch of this mission at 2:38 p.m. local time or 1:38 a.m. UTC.
No, man.
We're targeting liftoff right at the top of our launch window with backup opportunities
Alaska.
available over the fortnight in case we need to scrub or stand down for any reason from today's launch attempt. We are also keeping a close eye on the weather off the coast where, for the first time, we have a helicopter stationed offshore, ready to take part in our rocket recovery operations by observing the return of Electron's booster from space as part of our work to make Electron the world's first reusable orbital class small rocket. This mission will be the third time we'll bring Electron's first stage back to Earth under a parachute before landing it softly in the ocean to be recovered by our recovery engineers on a nearby ship. We have water-landed Electron twice before on our 16th and 20th Electron launches, but this third time includes the introduction of that helicopter that will simulate flying in formation with the returning booster as a test for future attempts to recover the booster from the air with a helicopter instead.
Please
we
have
have
a camera
cameras
on that
stationed
thing,
on
please.
the chopper and will hopefully be able to bring you live views of Electron's return from space from about T plus 10 minutes after liftoff.
Give us some
Regardless
footage
of whether we
baby.
get those live shots, we will bring you updates throughout this broadcast on those operations as soon as we have them.
They do. Oh, Smirks. This is going to be freaking awesome, mate.
It's toggled and
people from New Zealand
successful.
don't say awesome. Can you give us a local dialect way to say this is amazing? This is freaking awesome, dude. Smirks, can you give us a loud
and
dialect,
LD
please?
confirms I'm monitoring mission.
On the satellites on board
Bro, that'd
today's
be
mission,
badass,
we've had
cuz.
to lengthen Electron in order to fit
Hell
the two
yeah.
Gen 2 satellites for Black Sky inside Electron
That's
fairing.
great.
These payloads are the company's latest
Relativity
observation
type, yeah.
small sat
This is
for
not
their low
relativity.
Earth
This is
orbit
Rocket Lab,
constellation.
different.
They capture high-resolution images of our
freaking
planet
sick,
that
bro.
are combined with Black Sky's artificial intelligence platform
Do you guys say
to
wicked
analyze
down
and
there?
make sense of
We
those
say wicked.
images, to track trends from a region's
In New
economic
England.
recovery from
wicked
COVID-19
cool there, guy.
through to international cargo transport,
Wicked.
and provide analytics and insights
Wicked.
to industries including infrastructure,
wicked,
land
bro.
use, defense, supply chain management, and humanitarian aid. Love at First Insight is the first of
wicked
3
smart.
back-to-back dedicated missions for Black Sky, with the next targeted for liftoff during a 2-week launch window that opens before the end of this year. The beauty of owning and operating the world's first private orbital launch site means that Rocket Lab is uniquely capable of launching to where and when our customers want to on their timeline. Black Sky and Spaceflight are using that advantage to launch these satellites quickly over the next few weeks and deliver insights to decision makers around the world faster.
New England.
Earlier, we caught up with Spaceflight at Launch Complex 1 to talk through the mission.
Go ahead.
Hello from Rocket Lab's Launch Complex 1. My name is Brian Hirsch, and I am the mission manager for several of our upcoming launches with Black Sky. With me today is Lisa Middlebrook, Spaceflight's mission manager for today's launch, who will tell us a little bit about Black Sky's spacecraft on board Electron today. Lisa, welcome to Rocket Lab.
Thank you.
Tell me a bit about Black Sky's spacecraft on board Electron today. Where are they headed to on orbit, and what will they do there?
We're adding 6 Earth observation satellites to Black Sky's global constellation. These satellites are manufactured by Leo Stella, a fellow space company in the Seattle area with whom Black Sky has been working closely with for years. They'll be heading to a mid-inclination orbit, which will allow these satellites to target a latitude band which is home to most of the world's population. These 3 launches will nearly double their constellation and further improve their ability to provide a rapid response to the changing world.
There's obviously a bit of a process to bring a satellite from a paper design to space. Tell me about the work you do as a spaceflight mission manager to help enable that.
On a day-to-day basis, it's essentially a project management role where the project is sending satellites to space. As mission managers at Spaceflight, we interface most closely with both the launch vehicle provider and the satellite customer. Our role begins the moment the contract is signed, and we carry it all the way through to launch, which is typically a 6 to 12-month cycle. While I'm the main interface, I have a whole team of people behind me supporting each mission. Right now, I'm helping coordinate the integration here at LC1. If any problems arise, it's my job to help clear the way to make sure that we can launch on time.
What's it like working and launching from Launch Complex 1 here in New Zealand?
Every morning when I head to the launch pad, I feel like I'm driving to the end of the Earth. The area around Launch Complex 1 is deserted. Other than sheep, cows, and the ocean, there's nothing until you get to the end. And there you have cutting-edge rocketry. And the juxtaposition of the two is pretty amazing.
This mission is the first of 3 missions by Rocket Lab for Black Sky. Does that bring any additional considerations to your job as the mission manager?
We have 6 satellites, 3 launches, and 2 clean rooms. It's a bit of an orchestration to layer the standalone operations of one launch with encapsulation of another. Meanwhile, the loading dock is getting ready to have 2 more satellites arrive any day now, but we're making it work.
What's it like to work with the Rocket Lab team?
Because Electron is a small class rocket, and on this mission, we're the dedicated customer, Rocket Lab is able to be extremely accommodating. The Rocket Lab team is incredibly smart, professional, and a real pleasure to work with. You guys make it easy.
Well, thank you, Lisa, for all the hard work you've put into this mission, and thank you to the entire Spaceflight and Black Sky team.
You can tell because the background audio is different between his and hers. That guy's talking to a wall.
Today's mission, combined with a satellite we already deployed earlier this year and the next 2 missions to come, represent the largest number of satellites Black Sky has committed to a single launch provider to date, and we are thrilled to be back on the pad for them once again today. A check-in on the countdown clock tells us we are just seconds away from the go, no-go poll for launch by this mission's launch director, Adam Slee. Let's listen in to mission control and hear how we are shaping up for liftoff today.
I'll go over there. Jeez. Stop that. You talk to a wall all day. I know! That's the joke! Game recognized game.
SLD on mission cord. We're proceeding with the go, no go sequence.
Guys!
Stage A, go.
Come on!
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
Here we go,
GC.
baby.
GC is go.
PLS.
PLS is go.
RSO.
Mission control or land center? I'll let you decide.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub is go.
And can confirm exec go. We're currently T-minus 11 minutes, 24 seconds and counting. We are currently go for the terminal count start at T-minus 10. From this time, the three-word procedure is in effect.
Three-word procedure is hold, hold, hold. If you call a hold, basically, if you call something over the main communications loop, basically they'll stop everything.
There you have it. That's confirmation from our launch operators that Electron, the payload, and our crew are ready for launch.
Judging.
And we will be proceeding with the remainder of the count. Our Electron recovery team stationed offshore are also ready to proceed. The T0 liftoff time remains 2:38 p.m. New Zealand local time, or 1:38 a.m.
Shares in this company, please go well.
Electron is a two-stage launch vehicle purpose-built as a dedicated rocket to small satellites. Standing 18 meters tall, Electron's iconic black look comes from its carbon composite structure that is both incredibly strong and extremely light, allowing us to really optimize the vehicle's lift capacity for its size. Electron remains the world's first carbon composite rocket to reach orbit and also boasts another world first in its 3D printed Rutherford engines that power both the first and second stages of the vehicle.
It's got EFI too.
These engines are fueled by a mix of liquid oxygen and RP1, a highly refined kerosene,
it's electronic
and
fuel
major
injection.
components like the combustion chamber can be printed within just 24 hours. We've flown more than 200 of these engines to space, with today's mission bringing the count to 220.
Black Sky.
Housed on top of the second stage within the fairing is our kick stage, equipped with its own Curie engine, flight software and other systems to function as an orbital transfer vehicle to deliver payloads to their exact destination in space. With the kick stage travelling at up to 27,000 kilometres an hour, inserting the payload to its specific orbital plane is a complex task that requires precision and flawless timing. It takes a dedicated team of engineers and technicians, hours of systems testing and checks and rechecks of every aspect of the vehicle and payload before our launch director gives the go to proceed with launch. Here's what goes into preparations and mission readiness in the hours before launch.
The countdown to launch is the most closely watched clock in mission control.
Fortnite. Look at those
Here
headsets.
are some of the things that take place at each milestone after the countdown begins. At T-minus 9 hours before launch, our crew are on site at Launch Complex 1 to configure the pad for launch and prepare to power on Electron for the day's operations. Meanwhile, our operators in mission control start checking in to their stations. At T-minus 7 hours, our operators will brief the launch director with a status update. Mission Control also receives its first weather check on what to expect at liftoff, including cloud cover and predicted wind speed at Launch Complex 1. Now, at T-minus 6 hours, our ground tracking stations begin to power up before Electron is prepared to go vertical on the pad. Soon afterward, Electron's Rutherford engines are tested with a short burst of engine fire to confirm all systems are operating as they should. At T-minus 5 hours through T-minus 3 hours, our range safety team runs through safety status checks for those on and around our launch complex on the peninsula, making sure the team and the public are kept safe during the day's launch attempt. Fuel loading of kerosene will soon begin on Electron, while additional vertical systems checks take place and the pad is evacuated. It's T-minus 3 hours now, and soon liquid oxygen will begin to flow into Electron. As the rocket slowly fills with this oxidizer, Electron's black body turns white as humidity in the air around the rocket freezes into a thin sheet of ice due to the freezing temperatures of the liquid oxygen inside. With 1 hour left to launch, it's crunch time for our operators. Vehicle cameras are switched to their launch settings. Our avionics team enables Electron for flight. Our final weather brief comes through, and the range safety status will confirm that the area is clear for launch.
This looks so fun.
With 12 minutes left in the count, our launch director runs the go, no-go poll with our operators to make the final decision to proceed with the launch. All final checks are completed before we reach T-minus 2 minutes in the countdown. At this critical point, the countdown auto sequence begins and Electron's flight computers take over. The launch director begins counting down to liftoff from T-minus 10 seconds before the engines ignite 3 seconds before launch, and Electron lifts off the pad at T0 on its way to complete its next mission with the satellites on board.
Petty, you said most rockets are loud enough people can't be anywhere near. The Electron is smaller. What's the safety zone for the launches? It's about the same, dude. It's about the same, just to be very sure. I mean, a rocket engine's a rocket engine. It doesn't matter if it's small or big. Sure, bigger ones are louder, But that's like saying a handgun going off next to your ear and a howitzer going off next to your ear. You know, the handgun's going to be better. No, the howitzer is louder than the handgun because more energetic reaction. But also, yeah, you really don't want that first one either. Yeah, I wouldn't. I mean, you could probably watch it from where the cattle are. That'd be fine. It'd be loud. You'd need hearing protection, or at least I would. I mean, from there it'd probably be like first row at a Slayer concert, loud, or like Formula One V10 loud, somewhere around there. I mean, if the cows can be there, yeah, a person would be just fine. It's just loud, very loud. But I can't hear you. Rockets are too loud. I know, right? Yeah, that's right, Jock. Yeah, the rocket. Like I said, it's like a firearm going off. Like, dude, you know, you could have like a BB, not a BB gun. You could have like a 22 go off in your ear, or you could have a Desert
Let's
Eagle.
delve a little bit more into how the
go
recovery operations for this mission will take place.
Also,
at around 2.5 minutes after liftoff, following normal launch procedure, the 9 Rutherford engines on Electron's first stage will shut down, and Electron's first and second stages will separate. Electron's second stage will continue with the Black Sky satellites to space, where the kick stage will later separate and deploy the satellites. While the mission continues, Electron's first stage will begin its descent. A cold gas reaction control system will position the stage on an ideal angle to re-enter the atmosphere and help Electron to handle the 2,200 degrees Celsius heat and incredible pressure it experiences on the way back to Earth. Electron's booster is expected to reach up to 8 times the speed of sound before significantly decelerating to enable a drogue parachute to be deployed. That will take place at approximately 7.5 minutes into the mission, deploying at around 43,000 feet or 13 kilometers in altitude.
Strong back arms
this drogue parachute both increases the booster's drag and stabilizes its descent as it approaches the ocean.
So, what she's talking about there is the rocket's made entirely out of carbon fiber. So the idea is that, you know, most bigger rocket first stages, you can't really parachute down. They're too heavy. They just rip the rigging apart. The fact that Electron is tiny to begin with, it's small comparatively to, say, like an Atlas V or a Falcon 9, right? It's a tiny little rocket, but that doesn't mean it's a bad rocket. And that means that you're afforded some things. Because it's made out of carbon fiber, it's really ridiculously light. So you have what's called a low ballistic coefficient, right, and a high coefficient of drag, right? When one is low, when the ballistic coefficient is low, coefficient drag's high. It basically, well, it slows. It takes a lot longer for it to come down. It's basically really light. The running analogy that I use there is that if you threw a rock and a piece of paper off the top of a building, which one is going to hit the ground first, right? The piece of paper is going to. The rock's going to yeet down to the bottom. Electron's first stage is afforded recoverability because it's so ridiculously light. They can use parachutes on it, and it also slows itself down a lot in the atmosphere because it's really light. Also, so that's why Rocket Lab wasn't originally pursuing reusability, but they figured out that you could get it done because this thing is so light. It doesn't need to do supersonic retropropulsion or anything. It doesn't need a thermal protection system. It slows down before reentry heating even ever. Well, reentry heating still does happen to an effect, but it's enough for the rocket to be able to withstand. Hey, Kraketh, give this up to Justice. Thank you guys, I appreciate it.
The pad
pretty much, Victory, yeah.
20-second launch from Launch Complex.
You'll pass it forward?
We're going to switch to the mission control comms channels now to listen in ahead of liftoff.
The other thing that's cool about this is that those Rutherford engines that they were talking about, they use an electric motor to deliver the fuel. Other rocket engines use a jet engine to deliver fuel. They have a jet engine, and then attached to the spinning part of the jet engine is a fuel pump. That's called a turbo pump. Most orbital class rockets use something like that, but Electron, because it's smaller, in the same way that you see more electric powered RC cars than you see like gas powered RC cars. It makes sense to do that. It makes sense to have an electric actuated motor. This thing actually has batteries, a ton of batteries on it, and they can afford that mass because the thing is so light, because it's made out of carbon fiber. So they actually have electric fuel pumps. And don't get me wrong, these electric fuel pumps ain't like the electric fuel pump that you'd have like on a car. Not even a Formula One car or something. These electric fuel pumps could drain an Olympic swimming pool pretty damn fast. They're really, really, really cool little engines. That's the namesake for Electron is because it has electronic fuel injection. Unlike other rockets that have turbopump fuel injection. So we're inside of 1 minute here. Bloke, 41 months. Matura with an 80. Not 60, not 70, but 80.
Stage 2 tanks are pressed.
Okay. Tanks are at flight pressure. Let's see what she does. I'm turning up the sound, dudes.
High flow engine purge is enabled.
How much fuel volume? Enough to sustain chamber pressure.
Deluge activated.
Enough for a rocket motor. I don't know the exact number username. They probably wouldn't share that information. Yeah, Erebors.
T-minus 20 seconds.
You're absolutely right. Telephoto lens. Look at the parallax front to back. Good call. I mean, of course you know that.
10, 9.
Here we go.
8, 7.
Because these things are electric, they go on real quick. Watch.
4, 3, 2, 1.
Bye-bye.
Firm liftoff.
It's a stampede! That's a new camera angle, guys. I haven't seen this one before. It looks like some condensation got on it a little bit, though. My neighbors hate me. I don't always watch rocket launches, but when I do, my neighbors watch them with me.
We are at T plus 46 seconds, and there goes another Electron on its way to space for the 22nd launch from the pad from Rocket Lab Launch Complex 1.
Yeah.
Soon the rocket will experience its peak amount of stress as it travels incredibly quickly over a large distance. This moment is called maximum aerodynamic pressure, or what's known as max Q, and is one of the first gates Electron needs to clear to make it to orbit.
Boys, go for throttle up. Goat at throttle. I see what you did there.
And past max Q.
Very nice. Freaking mint. Okay, max.
And we have passed max Q, and Electron is continuing the journey to space. Propulsion looks nominal on Electron's first stage as the rocket approaches the next major milestones of launch. In a few moments, Electron's 9 Rutherford engines will throttle down and then shut off completely to slow the rocket down. This milestone is called main engine cutoff, or MECO, and it occurs just before Electron's first and second stages separate. Once that's happened, very quickly, Electron's 10th engine on the second stage will light up to maintain its trajectory and continue carrying the two satellites
doing this, that's normal.
After these launch events are cleared, it's then that our rocket recovery operations begin with the boosters' descent back to Earth. But first, let's wait to hear the call out from Mission Control that those events have occurred successfully.
Yeah, telemetry is still going. Yep. And
15 seconds to be
little bit of fiery flames that you see down here, that's normal too.
MECO confirmed.
An engine cut off. Stage separation.
Separation successful.
Stage to ignition.
That looked good, guys.
There you have it. Electron has had a successful MECO, stage separation, and second stage engine start.
Footage doesn't
Stage
suck.
1 recovery operations will now proceed with the vehicle's successful stage separation. We are moments away now from Electron's fairing ejection. Let's keep an eye on our screens for that.
It's almost summertime down there. It has a good separation. Really, really clean. Fairing separation, you see it over there?
Separation confirmed.
Electron's fairing has successfully separated as we get ready to deploy the 2 Black Sky satellites to their low Earth orbit within the hour.
Oh,
in about 1 minute
sick,
or so,
dude.
Electron's first stage will reach apogee. Now, Now, when the first and
Never seen
second
that
stages
before.
separated, Electron's booster is still traveling at such a speed that it continues moving upward before gravity begins to take over.
Right, Patrick.
So once Electron's first stage
Brian,
reaches
what's up,
apogee,
dude?
or its highest point, the only place for it to go next is back down. We should hear that call soon from Mission Control.
The helicopter, the recovery helicopter, it's not going to pick up the booster. Rocket Lab's idea in the future is a booster that's going to parachute down, and a helicopter will basically snag the parachute with a hook, and they'll be able to fly the helicopter back to the launch site, or back to a recovery ship, right? Now, they're not going to snag the parachute with the helicopter this time, but the helicopter is going to fly next to the booster when it's parachuting down.
Okay, we
and
are
hopefully
just
we have
past
camera
T
views
plus
of that.
4 minutes into flight, and
Ian!
Electron Stage 2 is traveling
37
nominally
months.
at a speed of over 8,000 kilometers an hour and an altitude of over 167 kilometers. In less than a minute, Electron's first stage should reach apogee with orientation of the stage
Something
underway
like
as
that,
planned.
Chris, yeah. Booster's flipping. It'll be all right. It'll naturally stabilize engines down, Dat Boy, because the engines are heavier than the empty fuel tanks. So think bottle flip. You have a lot of mass down one end of the
Stage 2
booster.
propulsion is nominal.
So you have a lot of mass down one end, so it's going to stabilize
Stage
center of
1
mass
apogee.
first. Stage 1 is hit its highest point, or its apogee.
And with apogee confirmed, Electron's first stage
Watch,
is
it'll
officially
stabilize.
on its earthward trajectory. The next milestone in our
It doesn't
recovery
need to,
operations
WD.
will be the deployment of the first chute on Electron's booster.
No.
We'll stick with the camera views on the rocket for as long as we can, but a reminder, we do expect them to cut out at some point on that return.
No supersonic
Meanwhile,
retro
Electron's
propulsion with this
second
one.
stage engine is burning bright and beautiful on the way to orbit.
Doesn't need it. It's
the vehicle
carbon
is
fiber.
currently
It's
at
really
speeds
light.
of more than
Not
10,000
needed.
kilometers per hour and an altitude of more than 200 kilometers.
I just wanted you to say it. Fair? But yeah, Van, the helicopter has a line, right? It has a line with a drogue chute.
We have got some
attached
good
to it,
telemetry coming
and
in for how
basically
Electron is
flies
traveling
that
to low
tow
Earth
cable
orbit. If you are
through
just
the parachute
joining us,
rigging,
our
and it
20-second mission
grabs
is
the
going
parachute
well so
rigging.
far,
It's nuts,
with
dude.
the second stage traveling at more than 11,000 kilometers per hour, more than 214 kilometers above Earth.
Yeah, Delario,
Electron's
I don't
booster
blame you.
is now on the correct angle of attack to re-enter the atmosphere from space, where it separated with the second stage as per normal launch procedure a few moments ago. All systems are continuing
here she
to
goes.
perform well across both stages of the vehicle.
Yeah, Jerry, right? Right?
Our next launch event will be the battery hot swap set to take place on Electron's second stage. Because our Rutherford engines maintain their power source from batteries, at a certain point those batteries run out of charge.
Yeah, they're gonna
so we
dump
need
them.
a fresh new one to
See that
keep the
silver
engine
thing?
running.
Top right?
And what we do is we swap the power from
gonna
the
pop
depleted
off.
batteries to a third fully charged one, all while keeping the second stage moving
That
at
is
more than
very funny,
13,000
Pat.
kilometers
You
an hour.
funny too.
We'll hear that moment called out through mission control shortly before we expect to hear the next recovery operation milestone, that deployment of the drogue parachute. Let's listen in.
Okay, first stage views still look really good here. Recovery drop test footage to show later. Yep. Yeah, got a little bit of a breakup on the signal from the first stage there. Just a little bit. Oh, it's coming back.
Hot swap successful.
Battery hot swap successful. There
Battery
you go.
jettison
Dumping
confirmed.
the batteries. They'll burn up. Yeah, Ian, it doesn't
And
need it.
stage
It's
two
carbon
propulsion is
fiber. It's
holding
really
nominal.
light. Because it's really light, it basically slows down a lot faster. It has way less momentum than something that was made out of aluminum, right? No,
And there we
no
go.
SSRP
we
is
have
needed.
the good news of battery hot swap there on Electron's second stage. Next up in recovery operations will
That's
be the
correct,
main
Des.
parachute release.
Or
We
Dex,
should be
yeah.
hearing that
Mhm.
call shortly.
Yeah, the fairings and the batteries will burn up. The second stage is going past
SDS
the.
has saved.
It's going past the you don't need a heat shield velocity. Basically, yeah. Yeah, everything looks good, dudes.
HVB discharge holding nominal.
Okay. I don't know what the recovery calls are here, guys. They've never shown the first stage stuff live, so we just kind of got to listen in.
Stage 1 main chute deploy.
There was the call for a main chute on the first stage.
The parachute on Electron's booster has successfully deployed, and so our recovery helicopter is in the air on its way to get a glimpse of the booster coming back to Earth. All going well, the first stage should now glide gently toward the ocean, remaining in the air for another 10 minutes or so from the parachute's release. We'll bring you visuals from the helicopter if we can. Right now, though, high above Stage 1 recovery, Electron's primary mission is continuing nominally, with the second stage powering its way to low Earth orbit. In under 2 minutes, this stage will be approaching its next event, second engine cutoff, or SECO, and then separation from its orbital transfer vehicle, the kick stage, which will carry the two Black Sky satellites to their destination.
It's going to take forever to come back down.
We won't have an immediate engine burn on the kick stage following that separation, as it goes into a coast phase while it's in an elliptical orbit before its Curie engine ignites and jolts it into a circular path for payload deployment. We'll wait to hear that SAGE separation call come from Mission Control shortly.
This one has the chute. Future ones, Jock, will have the parafoil.
Guidance is in terminal, 25 seconds remaining.
Helicopter cam. Bro, we got helicopter cam. There it is. Come on, find that booster. Oh, he's looking for it.
And SECO confirmed.
Second stage engine cutoff confirmed. Stand by for the call for good
Stage
insertion.
3 separation confirmed. Nominal transport orbit
good.
received.
Good. All right, let's see what we got. No. Come back.
There you go, another smooth achievement of our latest mission milestone. The Rutherford engine on Electron's second stage has shut down as planned, and the kick stage has now separated on its way to payload deployment in about 45 minutes or so.
Didn't like it when the thing
Meanwhile,
rolled.
we are getting some views from the helicopter of Electron coming back to Earth. Hopefully we'll see that soon under a parachute. Our helicopter's role here is to maintain a visual connection for as long as it can, to record data of the first stage that will help refine our operations for future Electron aerial capture attempts. Electron has around 8 minutes left in the air before it reaches the ocean. We are going to take a break now, though, while the kick stage enjoys its coast phase around the Earth. Unfortunately, we won't have a live video feed of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of that occurring. That's expected to take place at around T plus 55 minutes into the mission. And of course, any updates we have on the final moments of our recovery operations, we'll bring them to you here live while we wait the end of the mission. But we will leave you with views from the helicopter if we can keep them up from the splashdown zone as long as we can. And I'll see you back here soon.
They're going to fly the helicopter next to it, Laggard. They're not going to try and catch this one. The next one, though. Hi, by the way. Long time no see, man. What kind of chopper is it? A spinning one? Oh, nice. Come on. Look around. You'll see the parachute, guys. You'll know it when you see it. Yeah, I think this is every day's footage, Metreon. I think you're right.
Discovery, go and throttle up.
Come on, more helicopter. Please? Please? They took off from Tal. The solid line is where it's going. The dotted line, the dotted line is where it's going. The solid line is where it's been. Hey, Rocket Pilot, 34-month resub. It's not a sky crane, guys. It's a 3-rotor helicopter. I forget. Hey, Timmy. We want to see the helicopter. It's fine, dude. It's fine, dude. Can I have a heli, please? They did do helicopter on Mars, you're right. So the booster has, I think, about like 5 or 6 more minutes of flight time, so there's still time to see some, oh, they got a heli picture. Oh, yeah, yeah, I gotcha. Did you say, it has 3 rotors. There's pictures of it in Sean's link. They're ground stations, Tal. Yep. The one at the Cape. Cape Canaveral? There's no ground station in Florida for this rocket. It's a Eurocopter ES-350. Thank you. Dude, this song has that modulation in the background, and it sounds like a helicopter. Yeah, this is Timmy, Booger. Go ahead. It's too far north, Kuro. Kuru is over here. Kuru is right there. Cape Canaveral is right there. Wallops is right there. Kodiak is right there. Mahia, where they launched from, is there. Woomera is right there. Tanegashima is right there. Wenchang is right there. Jiquan is over there. Vostochny is like right there. Plisetsk is over there. And Baikonur is right here. Actually, no, it's a little more to the left. Actually, no, it's about right. Right around there. And Starbase is right there. Can you find Brunei? No. Excuse me. Quaj is over here, where Falcon 1 launched from. Yeah, I'm not sure what that...
We are standing by for confirmation of splashdown of Electron's first stage from the recovery team. If we're not able to bring you live video confirmation of that during today's webcast, we will keep you updated via our social media channels. Meanwhile, we'll be back at around T plus 52 minutes with an update ahead of payload deployment.
Can you find Oslo? Norway. up here? Good. That's an easy one. They're not. This one's going into the water, S. I'm just kind of waiting. See if they give us an update. Where is Memphis? It's Tennessee. It's right there. What? Good name for a song. I don't know. We never saw the helicopter footage. I'm gonna wait and see if they show us some recovery footage. Hey, Bill, what's going on? What is the name of that Africa tracking station? I don't know. Where's Wakanda? I don't know. Find where I live. Morale, Brazil. That's easy. I don't know where Morale is, Joni. I mean, I know that Brazil's right here. You have Sao Paulo, Rio. Brasilia's right there. I don't know where Morale is. Where's Pakistan? Part of the map's cut off where Pakistan is. There's no Indian Peninsula here. Smirks, find what country you live in. Canada. Do you know where the Azores is? Between Portugal and the USA. The Azores. Yeah. Bermuda's right there. Yeah, it's right. It's true, Demo. It's true. Really, Tomast? Can you find the Chad Republic? It's somewhere right here. I don't know. We made it up. Never happened. We made it up. This one was invented by a writer. Never happened. Where's Alcantara? Like right there? It's right at the mouth of the Amazon. Yes, but where's Waldo? I don't know. I can never find him. Wait, what the hell is that then? What are those right there? I'm confused. Total fabrication. Baikonur is not on the map. Baikonur would be like right here, or like right here. This map, there's a significant part of this map missing. Yeah, Joni, maybe. What about Carmen Sandiego? I don't know. You guys tell me where in the world is Carmen Sandiego. Yeah, victory, right? Can you find the it's on the Bergeron Marchand line. If they're MIA, we're screwed, Corsi. She's at my place, Hat Trick Swayze. Hat Trick Swayze, nice. Great name. ¿Dónde está la biblioteca? No sé. Thanks, man. Yeah, no problem, dude. It's all good. least they show the ice wall, right? Yep. Can you find Null Islands? No. It's gonna be fun, Ryan. Can you find where Ferrari last won an F1 race? No? Well, the booster would have gone into the drink by now, so... I did, Ermac, yeah. Look at the scale of that map on the... Look at the scale of that map of the US and think about how much of that you drove across. I drove from here to here. Man! That is a pretty friggin' long way, dude. That's actually... Yeah, Bill, when you look at it like this, that's really far. You drove the length of New Zealand almost 4 times. Yeah. And before that, guys, I drove from here to here, and then back, and then that way. That truck did 4,000 miles, man. Imagine driving and not just taking a rocket. Well, one of those is a little less expensive than the other, man. Man, you just want your Rocket Lab stock to go up. Don't lie. Because I held Tesla too long? Hodl! Diamond hands, bro! Diamond hands! Imagine having stocks? Man, don't need to, because I do. Now what, Ian? Destroyed. Diamond hands, bro! Bull run! 100% of your IRA is Rocket Lab. Okay, when we get to 30 minutes, guys, I'm going to switch over to KSP and we'll get recovery pictures as I'm preparing the SSTO mission. Yeah, Ryan, it's up there. You need to diversify your bonds, fool. That's right, Benno. Man, across the entire Pacific in 30 minutes? Not bad. Nice. Didn't the last one not make it? No, it did. Nice, Ryan. That's cool. This is Timmy's music, yep. I don't know, Bill. Alright. Fellas, I'm gonna be right back. I'm gonna go take a stretch break, and then we'll start up KSP, okay? Burb. Ugh.
Discovery, go at throttle up.
Sorry, it took a little bit longer. Any word on recovery, guys? Just the music? Yeah, no, I had to talk to Brimo about something. You missed them showing Electron under main chute and splashdown. We just jamming to the music? Hell yeah. Well, Peter Beck says splashdown on the stage confirmed. Helicopter has eyes on it. Cool. All right. So, yeah, they're going to deploy actually in 5 minutes, guys. Or not 5. They're going to deploy at 55 past. Do we want to just watch that, or we want to jump into KSP? Or I could split box it if you want. I mean, I don't think they're actually going to show the deploy. They're just going to report it. If they're just going to report it, then I don't know. It'd probably be better if we prep KSP. So, I hope you enjoyed the Love at First Insight launch. That was a good little launch. Electron's a cool rocket. Good to see it. Good to see it flying again. That's pretty sweet. Let's see. What's the next rocket launch, just in case? Let's take a look. Oh, the next one we got Astra. Astra is at midnight on the 19th, so Thursday night into Friday. Cool. Well, we're gonna be doing that after. We're gonna be doing a long stream. So, yeah. We got Astra with Rocket 7. Speaking of that, there's actually other news regarding that. Astra is actually going to launch from Slick 46 at the Cape, which was a little bit of space news that I didn't get to. Slick 46 is a Minotaur launch site. It's the one that's at the very tip of the peninsula at Cape Canaveral, just the tip. So, yeah, actually really cool. They are the next rocket launch that's on the docket there. And then on the 24th, there's the DART mission, baby. The double asteroid redirect. The mission that SpaceX is launching to launch a NASA satellite called DART at an asteroid and hit it at 16,000 miles an hour to see if they can move the asteroids around. Yeah, very, very cool mission launching out of Vandenberg on the 24th. So that's a week. So yeah, we got, and then Pritchal is that Pritchal is that same day. Oh man, that Wednesday stream is going to be a long boy stream. Hell, Hydra, that's gonna suck. And then there's another Electron launch on the 27th. Asteroid Billiards, indeed. I think you already did a mission with Dart on Kerbin. Oh, oops. I will move right to after hours right now, Blinga. You want to keep that attitude up. When is James Webb? 31 days away. Daitor. What was the Rocket Lab payload for again? That was a Black Sky payload. Jack's observation satellite. Yeah. Yeah. Vincino Denelalido. 1 year. Thanks, man. Might as well just start the stream at 11. Yeah, right? Actually, Ismic, the right way to do that would be to go to bed right after 1 and then sleep and then wake up in the morning and start another